From being spun, hung on every word, yeah, every single one. So this is not for na-na, promise to say you na-na-na. Have all bad days, oh na-na-na. I'm hard to love, oh na-na-na. God knows I need you, oh na-na-na. And when push comes to shove, forever is never enough. And I'm with you and don't fall apart. You make me feel like I have all your beauty is my gift tonight. I don't wanna go another night. And when push comes to shove, forever is never enough. So this is my phone, na 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 phone, na 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 na. Slow, automatic, from a movie, cinematic. Your beauty is my kryptonite, and I don't want to go. So this is na-na-na. Promise to say you na-na-na. We have a man is na-na-na. I'm hard to love, oh na-na-na. I never thought I'd find someone. God knows I need you, na-na-na. And when push comes to shove, forever is never enough. When I'm with you, I don't fall apart. You make me feel like I have a heart. Your beauty is my kryptonite. I don't wanna go another night. When push comes to shove, forever is never enough. We're gonna still them, don't let them tear us apart. We've come through life, got it hard, and we just need one restart. Just tell me you love me, forever is never enough. Just tell me you love me, tell you love me, forever never enough. Oh, na 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 na. Oh, na 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 na. I'm running your way, but you push me away. Your lifeline, losing your mind. I'm here for you, babe. I've loved you the same this whole time. So tell me, what's on your mind? And I'm not here to hear you say you're fine. I can take the pain you hold inside. I wanna know, wanna see it. Can I feel your grip tonight? Can't get this off my mind. Does it only control you? Let me in, I'll help you out. I won't lose you this time. Can I feel your grip tonight? Can I feel your grip tonight? You think you're too far, but I'm where you are, you know. I said I won't leave your side. They left you bare, but I'm begging you, stare in my eyes for you. Yeah, I give my life. Yeah, I'm not here to hear you say you're fine. I can take the pain you hold inside. I wanna know, wanna see it. Can I feel your kryptonite? Can't get this off my mind. Does it only control you? Let me in, I'll help you out. I won't lose you this time. Can I feel your kryptonite? Can I feel your kryptonite? I wanna know what I said. Can I feel your kryptonite? I'm here to hear you say you're fine. I wanna know, wanna see it. Can I feel your kryptonite? Can't get this off my mind. Does it only control you? Let me in, I'll help you out. I won't lose you this time. From being spun, hung on every word, yeah, every single one. So this is not for na-na, promise to stay on na-na-na. Have all that days on na-na-na. I'm hard to love on na-na-na. God knows I need you on na-na-na. And when push comes to shove, forever is never enough. When I'm with you and don't fall apart, you make me feel like I have your beauty is my gift tonight. I don't wanna go another night. And when push comes to shove, forever is never enough. So this is my phone, na 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 phone, na 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 na. Slow, automatic, from a movie, cinematic. Your beauty is my kryptonite, and I don't want to go. So listen, I'm going na-na-na. Promise to say you na-na-na. We have a man is na-na-na. I'm hustleable, na-na-na. I never thought I'd find someone, cause I need you, na-na-na. And when push comes to shove, forever is never enough. When I'm with you, I don't fall apart. You make me feel like I have a heart. Your beauty is my kryptonite. I don't wanna go another night. When push comes to shove, forever is never enough. We put us together, don't let them tear us apart. We've come through life, got it hard, and we just need one restart. Just tell me love me, tell me love me. Forever is never enough. Just tell me love me, tell me you love me. Forever never enough. Oh no, 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 oh no, no,
Girls.
Hi! How does it know where we're going?
Yeah, that's her.
How'd you find out she was my great-great-grandma?
Smile.
Mobile order.
Thank you.
How do they know I wanted sprinkles? How do they do that? Wow! How did you find our new house?
Good morning. I'm Joshua Baer, the founder and CEO of Capital Factory. Capital Factory is the center of gravity for entrepreneurs in Texas, the best place to start startups in the US. Thousands of entrepreneurs, programmers, and designers meet day and night, in person and online, for meetups, classes, and co-working. That's how we meet all the best entrepreneurs in Texas and introduce them to their first investors, customers, employees, and mentors. By watching all of that, we're able to figure out who the best companies are and invest in them. And through that, we're the most active early stage investor in Texas. Welcome to Fed Supernova, presented by Deloitte. This is day 2, and it's off to a great start. Day 1 couldn't have gone better. We had hundreds of attendees participating all day long in many different aspects, not just watching the great panels and content, but actually interacting in epic office hours, meeting one-on-one with entrepreneurs, walking around the VIP lounge, doing networking on the networking section in Hopin, where they're getting matched up one-on-one with other people that they get to talk to, and many other things, browsing through the startup crawl and talking to all the startups. I'm sure I'm missing something because there was so much going on. It really was a great start. But for day 2, I have a challenge for you. and that's to focus more on the chat. There was some good chat going on, but the difference for this event between being really good and being amazingly great is going to be there. It's going to be in the chat. And so I challenge each of you is whatever session you're in, type something in the chat. Even if you just say hi, say who you are and where you're from. Ask a question. There can be a whole different discussion going on just in the chat. And that's going to really elevate everything for everyone. But what in particular are we looking forward to today in day number 2? A couple different things. First off, we've got our Cloud to Edge track sponsored by Amazon Web Services. And it's going to be a great day, starting off with Nick Chillian from the Air Force. And that's going to be one I know a lot of people are looking forward to. Also today, the Texas Military Department is launching TMDX, their innovation unit here in Texas, and with a presence at Capital Factory. And I know there's going to be a lot of interesting things there and success stories about how the Texas Military Department has worked with so many startups here in Austin and in Texas to help get them SBIR funding and get their technologies out into the field where people can really use it. And then, of course, we're going to look forward at the end of the day to the finale of the Innovation Combine, the AFC Innovation Combine. There'll be pitches going on all day, but at the end, you'll see the grand finale. So it's going to be an awesome day. We'll wrap it all up with the startup crawl again, a chance to go through the different lists of all the different startups where you can click on them, learn more about them, and actually talk to the people that are there. So really glad to have you here. It's going to be a great day. And again, just as a reminder, your job, the thing for all of you, the thing that's going to elevate this event and make it better for all of us is to really engage in the chat. And anytime you're watching a session or participating, introduce yourself, ask a question, respond to what's going on. We're watching that chat. It's going to affect what you see on stage. So jump in there and participate. Thanks for being here today. Thanks to Deloitte for being our presenting sponsor. And I'll see you around. I'll be in the chat. I'll see you there.
Well, thank you, Joshua. It is such a pleasure to be here. My name is Sandy Carter, and I am Amazon Web Services Vice President for Public Sector Partners and Programs. I've been with Amazon for over 3 years. I've had an exciting time. I was brought in to create our enterprise workload business, so I got to build some incredible things, both from a service side as well as some partnerships that we've introduced. Before I worked for Amazon Web Services, I was the CEO of an interesting startup. We did kind of a Myers-Briggs for companies to match innovation tactics. So this whole area of innovation and building is very much something that is very close to my heart. Before that, I ran AI and ML as well as IoT in the business and in the industry for IBM. Now, many of you know that AWS is very customer obsessed. And even our events, we like our events to be customer obsessed. And that's why I'm really excited about today. We're here with the Army Future Command, with the Air Force, with the Texas Military Department. Some of our great partners like Deloitte and Accenture are here with us today. And I think that's what makes a great event. You're going to hear from all different perspectives on topics from Devsecops to, women in tech. So it's going to be really exciting. And we're really appreciative that Capital Factory has brought us here and brought us all together. Capital Factory does a really nice job of bringing vendors in and commercial customers in, as well as some of the areas like the Army and the Air Force all together so that we can be stronger and better together. I was recently at a council meeting, and we had everything from startup competition to really assess some new innovation and technology that these startups were bringing to the table, to a great discussion about what does the Army need, what's the future of the Air Force, and what kind of technology needs were there. And one of the things I really love about Capital Factory and working with them is that they're very much focused on diversity of thought. They're women in diversity group with Capital Factory, but just also ensuring at all times that that diversity is taken into account. And I believe very strongly that diversity drives innovation, so it's a perfect fit. Yesterday, you saw Andy and General Murray speak, and I just wanted to double click on a couple of key points that they made that I think will be useful throughout these sessions. One, they talked about AWS is for builders. And I told you that's one of the main reasons that I came to AWS was to build. Amazon has been building for 13 years at the broadest and the deepest set of services. So whether you're looking at using machine learning or AI or quantum, we are always innovating on those services, always working backwards from our customers so that our builders are building the things that really matter. And that is true for our government customers too. We want our government customers to have access to all of the same tools that are available to our commercial customers and all those other things that are required. My team started a program called ATO, Authority to Operate. And what it does is it helps startups and partners to get their FedRAMP certification, something that's really important for government customers, or just helping customers move into our Gov Cloud. These things are essential to the business. And if you're a startup out there, we love startups. I told you at the beginning that I was a founder and a CEO, so I know exactly what you're going through. And I love working with startups, and we really grow with our startups. We find that when startups start with us when they're small, they grow up with us because of the credits, but more than the credits, the go-to-market, the mentoring that I know I needed when I was starting my company, as well as the technology. We've helped tens of thousands of startups. And in 2018, we gave away over $500 million of AWS credits. So we really want you to engage with us across both commercial and public sector. And public sector to us is very broad. It's education, it's healthcare, it's obviously state and local government, DoD, national security. Also, we just launched our space independent business unit. So check out that as well. We support over 7,000 different government agencies, over 10,000 different academic areas, over 25,000 different nonprofits. And equally as important to us is defense, intelligence, national security. I just talked to Dr. Porsha Crowe from the Army. We love supporting all of our government, especially those who serve us. Purpose is really important to us. So today we're going to be talking about taking cloud to the edge. It's such an exciting topic. You know, Gartner has come up with this new terminology called distributed cloud, about taking on-premises and edge devices to the public cloud. For us, it's all about edge computing. And edge computing just means that the computing is done at or near the source of data. The value prop is kind of obvious, right? You have lower latency because you're closer to the data. You have no network congestion because you're closer to the data. Amazon believes very strongly in the role of AWS and Edge, being very customer obsessed and very customer focused. We want to not only, though, talk about the technology of Edge and being at the tactical edge and all the things that come with that, the need for data, but we definitely want to hear from AWS customers about this and some of their mission challenges. So without further ado, let's get on to the meat of the program, which is hearing from these customers and partners of ours, really discuss what's happening and to challenge you to take some actions that may be different than what you're doing today. Again, thank you so much for coming today, and thank you to Capital Factory for hosting today's event. Let's get started. As all of you know, AWS is very committed to builders. That's one of the main reasons I came, was to come and build something new. And I know that's what all our startups and all our partners and all our customers out there are looking for as well. So because of that, we always want to start out being customer obsessed. So we are thrilled today to have Dr. Porsha Crowe. And Dr. Crowe is the Chief Data Officer for the Army Future Command and Network Cross-Functional Team, which we will now call CFT as we go forward. So welcome, Dr. Crowe, or as you told me, I could call you Porsha, I think, right?
Yes, please. Thank you. Thank you for having me, and I'm very excited.
I am so excited too. Could you just give us maybe one or two words about your kind of your background and your history?
Sure. So as you said, my name is Porsha Crowe. I'm the Chief Data Officer for the Network Cross-Functional Team, which is under Army Futures Command that is headquartered in Austin, Texas. My director is Major General Pete Gallagher. And just a little bit of the network CFT, if you don't mind, I'll go into a little bit of the introduction. In coordination with our key stakeholders, we deliver the Army a network that enables our Army to fight and win and dominate in a multi-domain environment by 2028. And we ensure that we're building the right network for the future Army to include our partnerships, industry, academia, and bringing in the innovation that allows us to be dominant in that space. We have 4 lines of effort that are key, I think, for this audience to understand a little bit more. One is integrating the network and transport, because we know without that integration and the convergence of those networks and transports, we can't do things like data and some of the other important initiatives that we have. Common operating environment, which is really converging a lot of our software and hardware in the tactical environment to include our sensors, data, applications, effects, integration. Also, a line of effort is interoperability with joint and coalition accessibility, because the Army doesn't fight alone. We need our partners in our relationships, and we have to be able to share data with our joint and coalition partners. And lastly, our mobile and survivable command posts. So in the small, agile team of experts that we have on the cross-functional team, we really rely on our team of teams across our science and technology, acquisition, our testing. We also have great partnerships with our other cross-functional teams under AFC to include the Artificial Intelligence Task Force. And again, our industry partners and our relationships are really key for us meeting our modernization priorities. In my current job as Chief Data Officer for the network cross-functional team, Major General Gallagher realized that there is a great push on streamlining our data environment to support our warfighters. So he created this position within that team to kind of pull some of those entities and the partnerships together to make sure we have a clear roadmap moving forward. So a lot of that is in accordance with our DoD and our Army cloud and data strategies. And specifically for the Army's tactical environment, which I think we'll get into a little bit more. And just, I help ensure that we have the right investments, architecture, and the technologies to support those critical missions and to support what we're trying to do from the enterprise of the Army all the way down to the tactical edge.
Wow. So, Porsha, that's a big job, and we all know how important data is. So I'm so glad that you're in that role today, for sure. So based on all of that you're talking about, I would love to know kind of your top 3 challenges that the CFT or that cross-functional team is facing. Is it, learning and understanding AI ML? Is it the data? Or is it something else? What kinds of things are you facing today?
Sure, that's a great question. I mean, we have a lot of challenges, and I like to think that as we solve them, it may be for the current effort, future effort, but we want to stay, active with the community and ensure that as technology progresses, that we have a plan. So we're remaining flexible in our solutions. I would just start with like cloud computing in general. Where we're allowing on-demand access from anywhere at any time, sharing a pool of computing resources. But in the tactical environment, you have people and things constantly moving. We're setting up, we're tearing down equipment, we're reestablishing and establishing connections at different locations, such as mobile devices, headsets, servers, vehicles. So we have to be able to operate in a disconnected, intermittent, limited, and unreliable environment. With that alone comes a lot of challenges. And so when I kind of think through the problem statement, I'm thinking access to an enterprise data cloud may not be available where we need timely data at the device level edge nodes. So we also have to be able to accelerate the speed of decision making and deliver those capabilities to increase targeting, fires decisions, and And for example, what my mantra is, having the right data at the right place at the right time. So some of my challenges that we're facing is we want as much automation as we can and as much intelligence to the edge that we can accommodate per the resources that we have. Now, I know that's easy to say, but how do we overcome some of the bandwidth deficits and the other obstacles as I've laid out the tactical environment? So we're designing and developing with the mindset of sending not all data, but only the data that we need, and doing the heavy computations offloaded or preloaded on edge devices so that we can filter where we need the data and how much of that data do we really need to meet the soldiers' mission. I also would say efficiency of compute capacity built into our software and the equipment. And so as we look at industry offerings of containerization, elasticity, scaling for efficiencies, I think are very important. Some of the ilities that come to mind are flexibility, portability, simplicity, commonality. And so as we utilize things like containers at the enterprise, I also want to be able to utilize those containers down at the edge. And so kind of reuse where we need to and only be unique where we need to. I also believe a challenge is management controls and tools. So we need tools that are easy and secure and to be able to have good configuration hygiene as we have a very distributed architecture, and so as we have many multiple nodes, sensors, clouds, we have to be able to manage all of that effectively and share those resources across the network. And so, and I'd like to hear some of your thoughts, Sandy, actually. It was a great question. I hope I captured the essence of it.
Yeah, you did. It was really interesting. I think you first talked about automation, and Amazon also believes very heavily in automation because that's kind of what our portfolio does. We have 10 data movement centers. We have 13 analytics services. We have 24 machine learning, 18 security and governance, and all of those are about how do we help customers like yourself move data? How do we ensure that that's automated as you're going forward? You also spent time talking about the edge, and I love the edge, but just so that folks on the line, in case you don't know what we're talking about, so the edge is really simple. It's just about getting the data and the compute as near to each other as possible, which means that then you don't have to worry about latency, or you shouldn't have to worry about latency. You have that ease of network congestion because you don't really flow over the network as much. So there's a lot of value in having things closer to the edge, as well as just being able to run disconnected. And that's, again, something that we are very much pushing the boundaries of the cloud on. We built services to enable customers like yourself to innovate at the edge, like Greengrass, which is software that goes on devices and allows them to have that compute and storage that you can process data and take action. Or 5G, we created Amazon Wavelength to get you 5G. Or, in some instances, I don't know if you've seen our snow cone. Have you seen our snow cone yet? Mm-hmm. It's 5 pounds, so it can fit in your hand or in a mailbox, but it has all the power of that data that you might need in a disconnected environment. So I think this utilization of on-off premises, being able to deliver tactical edge applications, and just accelerating that automation, it's really where we believe that compute is going. And I'm really happy to see that we're kind of on the same page with that particular focus.
Yes, and I believe that, we focus a lot on the technology, and sometimes it's not the technology that is the issue, right? So, we've got to think through the whole ecosystem of training our soldiers. So if we do bring a new piece of, equipment, does the user have the right skill set to be able to do this? How long is it going to take him to do things? And so as we're trying to get faster decision making, especially in our targeting and fires cycle, we want to just make sure that we're thinking through that, the policies, the security, the training. And so, we can have multiple in that space and multiple vendors playing in that space. And we have to be able to work together as an ecosystem to ensure that we've got end-to-end, productivity and optimize what we have. So.
Yeah, I think that's right. And I think that a lot of times people do forget to think about all of the softer things, the training, the governance, the tiger teams that you need. So I do think that all those are important as well. And that really leads me to our second question, which is, how is the Army under your leadership transforming as it adapts to this new cloud and data-centric environment? That's kind of a new thing, right?
Yes. And so I can tell you, I've been in the Army almost 17 years, industry prior to that. I don't want to date myself, but, I've been around in different, in the science and technology community. I've been in acquisition and now being at the network CFT. I can tell you that it is really an exciting time. I mean, we have really the senior leaders and our organization has really embraced thinking outside the box, reaching out to the startup companies, thinking through what does not even, 2028, but even just the nearer future really look like, and how can we, change the ways that we're doing things and think about different problem sets. And so as we look at our Army cloud strategy and our Army data plans, we have really given a lot of thought into how do we do these things faster, quicker, using experimentations to, have that learn and informing cycle as we push, new software and hardware out to the field. But I would say that together with the Army and industry and even academia, we have proven that cloud capabilities can improve our situational awareness decision making. And I think if we continue to design and build with continuous monitoring and increase, we can increase our security footprint. I think we've proven that. We've enabled a lot more encryption techniques within that space. And then, even as we look at cloud computing at the tactical edge, we have a lot of great technologies that allow the sharing of those resources of workloads and lessen the burden on our server computations, our storage, just even the physical footprint, that the soldiers have to, configure and manage and set up and tear down. And then, just ultimately supporting, a faster decision cycle to the soldiers. So I think we've made a lot of inroads. We're taking the best practices from industry and looking at innovation to incorporate a lot of the process, methodology, and the techniques. And I do want to add in, I never want to forget interoperability with our joint partners, right? I think that, we never fight alone, that we have to embrace and we have to share the right data at the right security levels as we work towards, embracing our digital transformation. And I think that embracing the flexibility to manage new data sets as we work through the complexity trade-offs is really important for us.
And I think, Porsha, a lot of, you sound like you're ahead of a lot of companies, because as I do EBCs, executive briefings, a lot of people will come in and they'll say, I want to focus on my machine learning strategy. I want to focus on artificial intelligence. But until you really have a great data strategy and you have that interoperability, you'll never get to really valuable use of AI and ML. So I'm really excited that, as part of the Army Future Command and the CFT, that you guys are thinking through data and that you are thinking through that interoperability, because I think it's so crucial as you move forward.
Absolutely. And I think that we have laid the foundation of what that data strategy looks like, not just even within the Army, but across our joint services. So the chief data officers get together, they meet, we have data boards within the Army that we're moving towards, enhancing our data dictionaries and our data roadmap. And how does that look, and the standards, making sure that we, just even down to the lowest level, utilize APIs in the right way and make sure that we can share data, securely across the network. And we're not afraid to make changes within the architecture. We're upgunning, the skill sets of our military and civilian workforce. So I think holistically, we've got a really great strategy. We're always fighting for investments and budget to make sure that we can do the great things that we want to do. And as we think through that, pull industry in with us as we go down this road, because we are learning so much from what industry has done commercially, and then how do we apply that to military?
Sounds like a normal corporation, like everybody's fighting for budget. Hey, I'm curious. I know yesterday, and I'm hoping that everybody saw General Murray and Andy Jassy, the AWS CEO, speak yesterday. They spent some time on COVID and the impact that COVID has had. And I know on a lot of our state governments, it's really accelerated their move to digital transformation. I'm curious about the impact that it's had on CFT. Has it sped you up? Has it slowed you down? The combination? Porsha, what do you see the impacts of COVID having on you right now?
I would say, under these conditions of COVID, it is a great test to our Army about how well we are, doing, with really just resiliency, right? So how can we continue our mission? Really make the right trade-offs of what we do, prioritize what we do, and move out, right? And be creative about some of those solutions. So this is another point where I believe relationships matter, right? So we work closely with the community to include C5ISR, our acquisition partners, our industry partners, on utilizing our tactical systems to respond to COVID needs. So we have managed to use, maybe take the same system that we would push forward into a fight, but also be able to use it locally at home and adapt to using our systems a little bit differently. We have also communicated our impacts on our industry base to include supply chain and support our critical mission, with the help of, our senior leaders, and letting them know what are the impacts on the industry base. But I can tell you that, overall, we remain focused on embracing that creativity. And I think some of our agile thinking that is due to COVID. And we continue to support our soldiers. And I think, like I said, the talent, as much as we can do virtually, so if we can train, military and civilians on some of our, latest modernized tools that we have, especially in the Devsecops arena. A lot of this can be done virtually, that we found where before, I think we used to think we had to be in a classroom with the teacher providing us that hands-on experience. But, we've, of course, even in the real world, a lot of virtual learning is taking place. So I think that, we're just trying to be creative and prioritize what needs to get done. I'd be interested in finding, what you thought and how you guys have adapted also your organization to COVID.
Yeah, it's really, I think, fascinating that working in public sector, COVID really helped to accelerate a lot of the work that we were doing in the same things that you're talking about, remote work. How do we help get people up and going on the cloud faster? Remote learning. We work with over 25,000 different academic and nonprofits who all needed to now do remote learning. Even call centers, how do I find out where my supplies are, whether that be food or hospital supplies or troops, right? How do I know where everybody is when everything has now changed? So COVID, you never want to celebrate a crisis, but I would say that the positives from the crisis have been that there's been an acceleration to digital transformation, which I think is going to be a powerful benefit to DoD, to Army Future Command, to our state government, local governments, educational institutions. I think it will be a really powerful move in the long term for sure.
I totally agree. And I also believe optimizing what we already have. We have so many assets, but we kind of trained ourselves to thinking about using those assets in one way, and I think thinking outside the box and being innovative, this, pandemic has really taught us how to do that a little differently, and really partner closer. So, what traditionally might have taken us a little bit longer to work through some of the acquisition and the contracting, I think we have found ways to speed up some of those cycles. So a lot of great improvements. I hope we don't lose that, but I think that we are learning, and you're right, definitely a faster track to digital transformation.
Yeah. So now that we're looking at that, I know a lot of our startups, we have a huge array of amazing partners, some of which have sponsored today, Deloitte and Accenture. And then just, companies who really want to work with you guys. What advice would you give them today?
Great question. I would say probably first and foremost that technology is great. We rely on it so very heavily, but we operate as a system of systems. And so I believe understanding how your particular solution integrates into the bigger picture is crucial, because, like I said, we don't operate alone. We don't fight alone. Your system will not, for the most part, it will be connected to a larger internet, if you will, of things. And so how do you take your solution and just understand, the environment that you need to play in, who you're going to touch, what your everything from the standards that you use to how you're distributing, synchronizing data, doing data analytics, and think about the end user. We have users on how to use your solutions. And so the easier that we make it, the better. So just thinking about the larger picture of how your solution fits in into that system of systems, I think is really critical. I also think about commercial solutions. We're often, have the mindset of let's take commercial solutions. I think we have to really think through how do we do that and apply that to military applicability. And so, like I said, I love the thought of just be unique where you need to be. But a lot of commercial solutions don't really apply to certain solution sets. We have to be, mindful of how do we take something that works great on the enterprise, and then how does that work in a disconnected, intermittent, environment. And most of the time, but that will mean changing your system and making sure that you design and develop your system, in the beginning with those things in mind. And then also don't underestimate how big the Army is, right? So please take into consideration scalability, and then your expectations for, if we love a solution and instead of like 50, you're thinking 50, we may need 100. How do you scale that? And then I would say think about your partnerships, because there are partners that have the ability to scale that, that you may not have. So I think partnering correctly, with thinking of scalability, not just of your technology, but then how are you going to produce it and scale that out.
Yeah, I think that's great advice. So interoperability, make sure you're seeing yourself as part of a whole, not being the only thing, making sure you can scale up, because you guys are huge. You're huge, huger than even I thought when I studied before I came to this interview. And also making sure that you have that leading edge innovation, right? You guys are looking for the future, not the past. And so making sure that comes into play too. Now, the next big question that I always get, and I just came into public sector about 9 months ago, is the mechanisms for contracting. So what suggestion would you have on programs or vehicles or opportunities to partner with you guys? What recommendations would you use on kind of pathing that out and getting to the right person, if you would, or the right program?
Oh, that's a great question, Sandy. And as many technical exchanges that I've done, in my career, we get a lot of the same questions. It's probably easier for a big company to break in and find, the strongholds. Most likely they're already working within the military or the DoD. But we do have several mechanisms in place. So we always conduct continuous market research. We actually even have a chief warrant officer who is our chief of market research for the network CFT. So to work directly with us, we actually have a great point of contact entry. We meet with industry, for an hour or however long it takes, and we really try to understand, the technology. We give guidance back, and then, because we are a team of teams, it may not fit what we're trying to do specifically at our time. So we will, have that company reach out and give them points of contact, whether it's science and technology, could be testing, it could be another CFT that could be interested in that technology, and also our program managers on our acquisition side. So we really try to, bring in, our partners to see where that mess, and sometimes it may not meet our need. And so we try to give advice. So having the point of contact for our chief of market research, I think, is really important. Most of our partners have a point of contact that we can get into. So doing continuous market research, we know things change all the time. We're trying to be, agile in the way that we kind of move across some of the, our big portfolio industry solutions. We also do technical exchange meetings with our partners. I think we have had at least one or two per year. And so that gives industry an insight into where our biggest challenges will be, what capability set, we're talking about in the larger grand scheme of fielding some of those solutions. We also, during those industry engagements, provide details on prototyping and possible contracts that allow us to determine the maturity of that technology or possible inclusion into future large-scale assessments. We also leverage our S&T partners with our what we call a Cooperative Research and Development Agreement, or a CRADA. So that allows industry to partner formally with the government and be able to assess technology. And like I said, we do several engagements just even around the Army. We have several technology searches. We partner with, the other services to be able to do those outreach events. And we really try to publicize, some of our, what our needs right now, as well as what we might need in the future. And places like the Army Applications Lab, Capital Factory. So we really do try to get out and expand our reach and do the right outreach.
Awesome. That's great.
So, Sandy, if you don't mind, I'd like to ask you a question.
Yeah, I'd love it.
So from your lens, how can the Army better take advantage of and integrate proven commercial capabilities in the future? What are your thoughts on that?
Well, I know that you're doing some, and like with your director of research, but the first one, I would say, really falls into an Amazon leadership principle, which is learn and be curious. We have so many use cases that are coming out, and they're coming out rapidly now, especially with what's happening with COVID, of new areas and new focus, from quantum to AI, ML, to what we're doing with IoT. The industry has seen a 400% increase in the use of IoT and sensors, which you would imagine with COVID. But we're learning a lot about that, and we've got a lot of new use cases coming out. So I think one is what you're doing in a broader scale, looking out there to see what's available and what others are doing. Even, I know you guys attend some of the conferences. We just had a public sector summit online, but even going to conferences like reInvent, where you're going to see not just public sector customers, but also the broader set of commercial customers and what they're doing. I would say that would be the first one. The second, I really like, because you talked about doing experimentation. And we at Amazon believe very powerfully in experimenting, trying something out, doing a proof of concept. Maybe starting out with one of our startups and trying a new area, or working with us on a particular new area directly or with one of our partners, I think is another way to adopt some of these commercial concepts in. I know that you have to, we also have to ensure that they're ready to go for you. So identifying for vendors like ourselves, some of those solutions that you want to have FedRAMPed. We have an authority to hire or operate ATO program that we help startups and partners get that FedRAMP certification, which I know is so crucial for working on many of these projects or to get them moved into GovCloud. So I think having you identify some of those ahead of time would be interesting. And then I think the fourth and final area would be to do some big visioning with vendors or your partners. So we have something called Envision Engineering. And what Envision Engineering does is it enables us to brainstorm together to use some of the processes that Amazon uses, writing press releases, thinking really big and, not just about today or tomorrow, but what's going to happen 5 years out. And then we help you envision that and create not just the technology, but the user interface and the elements around it that you would need to be successful. So just listening to you, it sounds like you've got some of the pieces that you're already doing that with today. And I think just adding in and getting that closer, tighter partnership would be a great way to leverage some more of those commercial technologies and approaches as well, right?
Definitely. Great points. I do think that we have a great, outreach. We can always do better. Like I said, we are such a large army. Things do change pretty quickly. We do utilize a lot of the social media avenues, especially now with COVID. I know that we can't really be face to face and do trade shows and things like that. But I think virtual, just collaboration and the way that, like we have today is really key that we continue to maintain and keep the information flowing both ways.
Yeah, I agree. And I would say that virtual is a great equalizer, right? Whereas maybe before you wouldn't have felt comfortable going to Vegas. Now that we have everything virtually and online and available, it opens up a lot of doors, I think, to everybody. And we appreciate and love the partnership that we have with you guys. You guys are some of the very best in this particular space. I'm sorry, I interrupted you, Porsha.
Oh, no, I was just going to say that, I think for some of the startup companies too, that may not want to invest a lot of travel time and money, this is another way that we could collaborate a little bit closer.
Yeah, in fact, Capital Factory had me judge virtually a startup competition. It's amazing. They did such a great job at having the startups pitch online. So we should do something like that as well.
I agree. I think that, we as a community have some really great thoughts. I think if we can filter, some of those, the way that we can utilize, our technology now that, the world is changing. We've got some really great opportunities to be able to reach out in different ways that we probably haven't thought about before.
Yeah, I agree with you. Now, yesterday, General Murray and Andy Jassy again were talking about initiatives to help that user and developers understand more. I'm curious to maybe double click on that a little bit more with what you guys are doing and maybe sharing some of the details and the techniques that you guys are using at the Army Future Command and CFT.
Yeah, I would say that we are following the trends and optimizing where we can by utilizing our, industry best practices and technology. So we are looking at industry to really set the pace together with our S&T community, and how do we keep continuing to push the ball forward. I think, we've got, vision for 20 months. I think that we can capitalize on a lot of great technology and what the future, even with what we've seen in academia, and how do we bring, that into, how do we start changing, looking at the infrastructure and the architecture and the platforms that we're using. And like I said, making today's current technology flexible enough that we're not throwing everything out when those new technologies come in. So we're really looking at industry, academia to set the pace for what the vision looks like in the future, and how do we bring that technology and capability into that environment. I think things like industry does very well with Devsecops, that we're not only embracing within the Army, but also with our Air Force partners. I think utilizing the processes and the methodology and the great tools that they have. I think training our military and civilians to think that way and use that, and then wrap a great technology, methodology around it, whether it's agile, lean, or extreme programming, to really, produce faster, more efficient and effective software is really where we're leaning in on that. I would also say that exploiting what industry already knows and is producing in terms of 5G capabilities, quantum, multi-level security is a really big area for us, especially as we look at sharing data with our joint and coalition partners. I believe the artificial intelligence arena is ripe with, of innovation of how we can utilize that, not only where we have, connected, reliable comms, but also down at the edge where it could be, intermittent and not as reliable. And then, what's near and dear to what we do, really for applications and data is how do we, find that compute and storage, utilization that really allows us to do our mission, make decisions faster, especially when you're talking about, sensor to shooter and, enabling that user to have the right data at the right time, at the right place. So I would say, given our goals of having an efficient and effective network, data interoperability, we want to produce the best value and outcomes for our soldiers and our end users. So we are embracing, the industry, the trending and the new innovations. And I think the partnering with the S&T community allows us to look out a little bit further. And so, I love doing, things like this with you and other partners, is because this is how we learn. This is how we trade ideas. And, the follow-ups from this are really the important part, right? And really digging in and finding out what you guys are thinking and what you're doing in this environment is really key.
Yeah, it was interesting when you were talking about DevSecOps. I've heard that now more from commercial, and it started with you guys in DoD and Army Future Command, and I know we have a session later on just on DevSecOps. That's a great example of how public sector and DoD's kind of set the bar that's now being adopted by commercial. So I thought that was kind of cool as well.
Yes, I'm really excited about that. I have learned and have experience in DevSecOps through industry with our vendors and the way we partner. We've put out, we fielded software using this before, so it's not new to us. I think what we're trying to do now is really standardize it and make it common. And like I said, only be unique where we have to. We do have mission spaces that require us to be unique. And then learn and adapt, everything from the way we do acquisition and contracting to onboarding new vendors that might have a great idea and can come into our space and see the services and our libraries and our APIs that we have to enable them to, produce integrated capabilities and give that back to the government. So really exciting space. I think we have a lot of opportunity. And again, we're just trying to keep pace and modernize and digitize the transformation of what some of our, environment here.
Awesome. So our next question, we're going to talk a little bit about a subject that's very passionate for both of us, which is women in tech, right?
Yes.
So let's talk a little bit about that area. Would you like to start us out?
Yeah, I would love to get your thoughts about what do you see as the challenges, maybe even opportunities that you're seeing for women, and how can we encourage more females to join STEM-related professions.
Yeah, so I think it's really cool that 2 female tech leaders are on the call today, and both very passionate about how we take that next step so that this is not that this is a norm, right? This is the new norm, I guess you would say, is to have lots of women doing this. So some of the challenges I see are first of all, the pipeline, right? How do we get more women into the pipeline itself? I'm a big proponent of Girls Who Code, Black Girls Code, Hispanic Who Code, because they start early on. In fact, my daughter, I have 2 daughters, started with Girls Who Code, which really got her excited about Python and the potential that was there, making it interesting and fun. I think is really important, making sure we have that pipeline that continues to grow. Porsha, when I went to college to study computer science, there was only about 20% women. And I was hoping that when my daughter went to school, the numbers would have changed. And they really haven't so far. We do need to do more in that younger age. I also, go ahead. Do you want to add something?
Sorry. No, I agree with you wholeheartedly on that.
Yeah. And that's all, that's getting everybody excited about technology. The second thing that I see is this, kind of career progression. So as I mentor women, especially in tech, I see a lot of the bro culture that emerges itself. And so I think we need to build inclusive environments. And I know that has now kind of taken a life of its own on. I'm hoping that it won't be a moment, but will be a movement, that we start making the work environment included enough to where people ask, what do you think? Not just kind of bully over it, and really take advantage of diversity. I believe that diversity yields greater innovation. So I think that it's a really powerful tool. And then the third big thing that I think is a challenge is just, I believe very strongly in, you've got to see it to be it. So you're such an inspiration. You tell me don't say doctor, but I wanted to say doctor because I want the next generation to know you can be a doctor. Here's a great role model. So I think you do have to see it to be it. I think we need more role models, and I think there are more out there. We just need to make them more visible as they move forward. I do think we're working on a lot of these. I do think that things like Girls in Tech, who teaches women not only coding, but the way to interact and the way to have confidence and the way to really help drive that change is going to be really important. I think putting up more role models is going to be really crucial as we move forward. And just doing things like hackathons. I have a friend who is the CEO of a startup. She's probably one of the most visionary women that I know. And she's created these little robotics kits. So you can either use it to make jewelry and fashion, or you can use it to make a robot that moves. It really hits like every single interest area. It's not segmented to one area. And even at Amazon Web Services, to teach machine learning now, you can have a little deep racer car, which is 1/18 the size of a real race car that has IoT and ML, or you can do a camera, or you can do a deep composer, which is music. I love the fact that we're starting to see some progression in the way that you learn as well. That's more diverse in its approach. Do you agree with that?
I am so passionate about everything that you said, and being a woman in this field, and actually I moonlight as a professor of cybersecurity. So I have had the pleasure of teaching Girl Scouts come in. We do a role play on cybersecurity. But the one thing that I do see is hitting the K through 12 education system in the area for STEM, getting our children started earlier and giving them the confidence. So I think a lot of the hands-on, my daughter too has built drones and flew them, and thinks it's really cool, and I love that. So giving her that hands-on experience and not making this nebulous thing is really key. So I would continue to, tell our younger generation and hopefully our educators that, we have to start early. We have to make an impression early. And we have to give them the hands-on capabilities to be able to do that, whether that's, programs during the summer or after school curriculums. But just, I think, giving them the confidence to say, it's not an unknown thing. And, if you like it and you're having fun, then keep going. And there's opportunities for them to do that. So I love being involved in this. And so anywhere I can help to progress the field I'm in.
Great. So thank you. So you know what, if you're a young woman out there or you're an experienced woman out there, reach out to either myself or Porsha as well. Dr. I'm going to say Dr. Crowe, we do have to start wrapping up. So what I'd like to do is to have you leave us with 3 points. So if you wanted everyone to take away kind of 3 things from your just action-packed fireside chat today, what would those be?
I would say, I do want to say thank you for your time today. I really enjoyed the session. I hope that it was really helpful for our audience to, really kind of understand where we're going in the data and cloud and some of our initiatives. So first, I would say the Army has a vision. We know where we need to be. We have a detailed plan and timeline of how we're going to get there, and we are being accountable for our progress. To make significant progress, we are maintaining our relationship with industry, our partners, and academia. So, I would say that first. Second, I would say that we cannot achieve our goals without our partners, right? And so I do want to continue the outreach. We have, like I said, a market research person on our team. There's a lot of us that, we do meet and engage with industry and just doing continual outreach with the community and keep you up to date with what we're doing through our technical exchange meetings and other venues. And lastly, just to kind of round things out, I would leave you with a couple thoughts. Costs, right? So I would say cost of your solutions, think about that. As you scale, what are those licensing costs? Intellectual property is something I would also ask you to think about. That's always a challenge of what you want to maintain versus the government and how do you work that transaction. So IP is really important to the government. And so I would say think about that up front. Also, security practices and the way that that you do code supply chain. We have to understand take what risk what we take on and making sure that we see ourselves in that whole entire end-to-end process. So those are just some additional things I would ask you to think about up front and incrementally throughout the process so that when you get to the end point, it's not a big, oh, wow, this is going to cost me a lot more money, or I should have designed or developed things a little bit differently in the beginning. So hopefully that kind of just wraps up some of my thoughts there.
That's great. Thank you so much, Dr. Porsha Crowe. It's been such a pleasure to have you with us today at this fireside chat. So if you're sitting there today, make sure that you do take into account the great points that she made throughout this session. Make sure you're thinking about your innovation. If you're a startup, make sure you're thinking about your interoperability, how you fit into the whole, the cost that she talked about, and just make sure that you remember the inspiration that she's brought to the table. I want to thank you for your service as well. This is a chance, I think, for all of us to bond together and do something that's bigger than all of us, is to really help out the Army as we move forward. I want to thank as well Josh Baer for the great sponsorship here with Capital Factory, helping all these startups to provide some of these great new ideas as well. So thank you so much. Really appreciate the time that you spent today. And audience, thank you guys for joining us and sticking with us throughout this session. Thank you.
Thank you.
Carter and Dr. Crowe, and welcome to day 2 at Fed Supernova. Quickly, I want to take the time to thank the team here at Capital Factory for making all of this happen. They're juggling 3 platforms in masks and gloves to bring all this magic to you and share perspectives from across our industry. I'm sharing some behind the scenes photos on Instagram at Defiant Comms if you want to see what it's like back here today. But if we haven't met yet, I'm Julie Willis, CEO of Defiant Communication, author of Conceal Reveal, and podcast host at Innovator Operator, where we dive into just how innovators can make the most of opportunities like this one and share the stories of defense innovation from the companies that are making it happen. This week, we spoke with Tamron Bates at AFWERX about the Tech Tuesday program, which you should look up. And next week, we're talking to the only company making gear by and for female operators. I love my job. Today, my job includes hanging out with AWS on the Cloud to Edge stage. We also have the TMDX launch presented by the Texas Military Department and the AFC Innovation Combine, culminating in the award ceremony at 2 p.m. Central Time today. So it's time to kick things off. Hop on over to your stage now, and we'll see you later. All right, let's get started with Cloud to Edge. The keynote is brought to you by Nick Shalon, and Q&A will be with Kevin Lantroop, Capital Factory's Vice President of Defense Innovation. Nick, come on up. Hi.
Hey, thanks for having me, and we're excited to be sharing today kind of the journey of the DoD to move to Devsecops with Kubernetes and Istio. We'll share how we managed to put containers and Kubernetes on jets and different DoD systems across DoD, and hopefully you'll have a lot of questions, and we'll have 10 minutes to answer some of your questions after. First, everything we do is open source, so it's pretty exciting to see. We have all the documentation, the source code repo, everything public for the world to see. So go to that website, software.af.mil. If you go in under the section DSOP documents, you're going to find all the links, all the recordings, all the videos, everything that explains how we've done what we've done in a year, both on the culture side, the technology side, the training side. And so hopefully that can become a live resource for you. We continuously update all these documents. Of course, the source code repo is accessible to anybody, so that's also pretty exciting as well. So when I look at the different ideas behind the DoD Enterprise Devsecops initiative, there are a few key components that were empowering the DoD to move fast to Devsecops. One is we wanted to avoid getting locked into a single cloud provider or platform. So we use Kubernetes and CNCF compliance, Cloud Native Computing Foundation compliance, to ensure we're not getting locked into anybody. And then we use OCI compliant containers. That gives us the ability to centrally accredit containers DoD-wide across classification levels. And my team, Platform One, is responsible for managing the central repo called now Repo One, used to be called the DCAR repo, which has all the centrally accredited and approved containers. So check it out on the website. You're going to be able to find both the source code called Repo One and the Iron Bank. And the Iron Bank is the binary side of all these containers that we centrally accredit both commercial products and open source software. So we have teams that work with companies across industry to ingest these containers and make it easy for companies that have software capabilities to get accredited DoD-wide and provide access in real time to their software releases. If you release 20 times a day, one time a month, does not matter. We automate the process to ingesting containers. The foundation of that is obviously on Kubernetes, and we use the concept of baked-in zero trust security using a sidecar container concept to bring a behavior detection and zero trust completely baked it into the stack. We use a Service Mesh Istio to do some of that. We'll talk more about that. But really, the reason why we were able to move so fast is by creating two teams. One is Cloud One. That's the Cloud Office team accessing both Amazon GovCloud and Azure Government to have access to two cloud providers. And we also have access to the IAC clouds, C2S, and fences for SAP. So that gives us kind of that multi-cloud capability and ease of access to cloud resources. Then, of course, we had Platform One on top of that. And so Platform One is the DevSecOps team. Platform One is agnostic, can be on top of Platform One, but it can also be on top of a weapon system, a business system, cyber offense, defense system, classified environment, air-gapped. We are agnostic. And so that is really kind of the beauty of Platform One. They can instantiate using infrastructure as code and GitOps principles, a DevSecOps environment on any environment, any classification levels. And we support multiple Kubernetes distributions. We'll talk about that as well. We created the concept of a DoD-wide continuous authority to operate, which is really changing the mindset of accreditation teams. Instead of accrediting the software itself and fast track the ATO, we accredit the factory and the software pipeline, DevSecOps pipeline, CI/CD pipeline, and define the gates, both in change management, cyber, and testing, to really validate all the necessary ingredients so that software that comes out of the factory is already accredited. And then we authorize teams that will be using the factory so they get the proper training and onboarding to be using the factory. And that is game-changing. That enables us to release software multiple times a day as needed based on the mission needs. We have 100,000 people we have to train, so we're bringing a lot of self-learning capabilities. We also partner with the AU to create the DevSecOps Academy. But again, with 100,000 people, we want to bring self-learning capabilities with unbiased content. So we partner with the Linux Foundation, the CNCF, and O'Reilly, the books, to provide unlimited access to all that content on the cloud. So it's not in a vacuum, and teams can put it to good use. Very exciting to see kind of the adoption we're getting. We now have the largest DoD programs using Platform One and DevSecOps, with teams like F-35, GBSD, Aegis in the Navy, and teams like Jake, the Joint Air Center as well. So really tackling all of the key aspects of software across the DoD, across all the services. This is not an Air Force only capability. This is a DoD-wide capability. DoD CIO just signed a couple of weeks ago a memo making Platform One the first DoD-wide approved DevSecOps capability. So why did we pick containers and Kubernetes? Again, one is abstraction, avoiding vendor lock-in. The immutability of containers give us the ability to centrally accredit containers and update layers. And so we have an OS hardened STIG that can be then shared across commercial companies and different layers. So if we have to update the base OS, we can centrally push these updates across all classification levels, streamlining patching and updating of all these Lego blocks. And so really using the concept of layers is game-changing. When you think of resiliency and self-healing, thanks to Kubernetes, that obviously brings a ton of value, particularly for weapon systems. The baked-in sidecar container stack that we built using open source and commercial cyber tools brings us the continuous monitoring and behavior and zero trust detection we need. The Lego blocks give us the freedom to swap things and try things out and be more adaptable. And of course, GitOps and IAC and infrastructure as code give us automation, right? And push button deployment so there's no drift between environments. Very important as well. Kubernetes brings also the benefit of auto scaling and abstraction, so we can run the same stack and the same application and the same platform stack on all environment, whether it's edge use case, classified cloud air-gapped, a weapon like a jet, or a space satellite, all the way to a cloud on-premise environment as well. So when I think of a DevSecOps stack and you look at all these pieces, and that's just one example, we have 170 plus containers we're supporting. Obviously, you can imagine if you had to update all these tools one at a time with VMs, that is obviously not feasible. You're gonna have drift, you're gonna have issues with different images and different formats on different cloud providers and on-premise environments. By having the ability to have the central repo of containers and centrally partner with the companies or the open source communities to update these Lego blocks in real time with complete automation and continuously monitoring CVEs and behavior of these containers bring obviously a massive benefit to the DoD in ensuring we're getting access to the best and brightest tools and capabilities, but also don't get behind when it comes to adopting new options. So everything we do is containerized. We don't run virtual machines when it comes to any of these tools. And we use the concept of layers with Cloud One that can bring the cloud layer, but of course we can also run on classified clouds and on-premise embedded systems, edge use cases, whether it's Amazon Outpost or Snowball or Azure Stack or vSphere environment. Then you're going to put Kubernetes on top, and we support multiple Kubernetes distribution, whether it's OpenShift, whether it's VMware TKG, Day2IQ Convoy, Rancher, Oracle, AKS, EKS, you name it. But on top of that, we're going to bring the CI/CD pipeline, all the containers, and then the service mesh. And the service mesh is critical to the east and west traffic management. For people that don't know what a service mesh is, we have great training on the website to go understand how we use Istio to do zero trust enforcement across the stack. So container A to talk to B has to be whitelisted to be able to do so. In effect, the application layer, what's left up there is only 10% left of NIST controls, and so inheriting 90% of the controls. And thanks to the continuous monitoring stack we have on the left side here, you end up really having access to a turnkey cyber stack that's going to run in runtime, in build during your DevSecOps pipeline, all the way to your production environment. So the key is not to take just containers and run them on bare metal, is to run on the platform in production as well. So when you think of Platform One, one of the prime enabler and why Platform One became a DoD-wide service is we see software factories popping up left and right from different services, and they all pretty much have to build the same stack and same capabilities to start producing software. We don't want to be in the business of building factories. We want to be in the business of building mission software. And so Platform One is a capability that any development team or software factory team or PE or PMO can use and consume to instantiate a factory, so you don't have to build the factory itself, but can use a factory to build software. And that is critical. And we partner with dozens of federal agencies outside of DoD, dozens of teams within the defense industrial base are using Platform One and pushing capabilities. For startups, it's awesome to be able to get accredited DoD-wide in a couple of weeks if they can push the containers to the repo one repo. So brings a ton of value. We have all these different teams across DoD, of course, consuming Platform One. There are dozens of them with all pretty cool names. Both Air Force, Navy, and Army are consuming different services of Platform One. We see Platform One as a company providing services. It is not mandated to use any of these services, but at the same time, it's streamlining access to different things. There's no reason to reinvent the wheel when you don't want to, and you can use as much or as little as you want when it comes to the Platform One services. Repo One is a source code repo. We have all the ISC automation Terraform code, so we're not locked into a specific cloud provider or environment. It's accessible to the world. Iron Bank now has actually 140 containers. The slide is not updated. So we have 140 containers available today. We're going to have probably 220 by the end of the year. So we centrally accredit and sign containers and provide a full analysis of risk for consumers of the container as well. So that's the Iron Bank. And then, of course, we bring different options of Kubernetes. We partner directly with the companies, whether it's Amazon Azure, Red Hat, Day2IQ, VMware, Rancher, Oracle. We have hardened versions of their distribution, their Kubernetes distribution on the repo when they provided it to us. We also built a matrix. You're going to find that on the website. If you go on the DSUP document section and you look for matrix and you don't know what Kubernetes distribution to use for your mission and getting stuff done, you'll see we collected data from each product to see who can do what, right? So if you want to run on real-time OS on an embedded system to be able to put the containers and Kubernetes on the jet. Very few Kubernetes distribution let you do that. So we track all these different capabilities and update this as a living document on the repo online. So again, no need to reinvent the wheel, hardening, staging, OpenShift or VMware or whatever, right? Rancher, Day2IQ Convoy or whatever. We have the code on the repo supported by the companies. The next piece is the two key services. We have the Party Bus and the Big Bang. The Party Bus is a multi-tenant environment. So teams that just want to get started in DevSecOps and they want to get access to existing environment at different classification levels. It's a pay-per-use model where we charge about $2,000 per developer per month to get access to the DevSecOps environment. It's both development, staging, and production environment with a full cyber stack. Ops includes the licenses, includes some of the cloud compute and storage baked in, and that is an easy way to get started and benefit from the continuous ATO to release software multiple times a day. And then the Big Bang is a more dedicated environment for bigger teams like F-35, GPSD, or JAIC. They would get a dedicated enclave where they get to pick the tools. That's a big difference. The Party Bus, you just are a consumer of the tools we picked based on demand, versus the Big Bang, you get to pick the tools you want to have, and we have contract vehicle to get the tools and the licenses and the support you need to instantiate that environment for you and manage it for you if you want us to manage it. Or you can also manage it yourself, and we just build the ISC and the code to automate its deployment. But most teams don't want to be in the business of managing that DevSecOps environment, and so they end up using our teams to do all that for them as a managed service. We created also the first cloud native access point with DoD CIO. So we partnered with DISA and DoD CIO to move the CAP, the cloud access point, to the cloud as a cloud native elastic resource to get access to impact level 2, 4, and 5 for dev, testing, and production environment, moving to a zero trust mindset. So we are moving from parameter culture to a full zero trust, enforcing device state and comply to connect, looking at things like the state of the device, whether it's on Mac OS or Windows or iOS or Android, whether it's a GFE, a government device or not, a bring your device, government device, or a contractor device. We can assess the device state and allow the device to access different things based on its risk and based on the user accessing as well. And so the compounded risk of the user identity and role-based access control and the device will determine what you get access to. And that's game-changing. That creates a real zero trust, granular whitelisting capability based on device state and based on the user role. We also have geofencing and time of the day and things like that as well. Some of the key components to train 100,000 people is we are making a ton of content available, both in terms of virtual onboarding capability and training videos and content. But we also are bringing 2 months, for example, full onboarding, where we embed people from Platform One into the program offices to define what the minimal viable product will be, and then be able to push at the same time, the ability to build that MVP and release it in production within a couple of months, and really do this as a team, so the team that's never done DevOps before can learn and get there faster together. When I think of DevSecOps, a key component is a bunch of managed tools. We have access to Diode to push containers from the low side to the high side. We have a bunch of tools we're bringing from chat to the GitLab of the world, to the GR Confluence of the world, to the cyber tools like Nexus Lifecycle, Black Duck, SonarCube, Checkmarx, Fortify of the world, to pen testing capabilities. A big component of continuous ATO is to continuously pen test both the platform and the application as well. So that is very important, and we do that fold the teams by leveraging partners in the pen testing industry to do this continuously and not once and for all. For companies that are trying to sell services or licenses to the DoD, we created the Devsecops basic ordering agreements, the BOAs, that is 3 vehicles: the cloud services, the tools and licenses, and the talent/services. And in effect, a program office can come to Platform One, pay per money, and either use the contract vehicle with their existing contracting officers, or use the contract vehicle with our contracting officers, and order within 30 days licenses, talent, and cloud services very quickly, to be able to get all the tools and the people they need, whether it's DevSecOps engineers, developers, site reliability engineers, and so on. And same for licenses. If they need 20 different products in DevSecOps that they need to acquire rapidly, that's a great vehicle to get this done under 30, sometimes 60 days, but usually under 30 days. Some people always ask me, what is really infrastructure as code, and what's the value there? And really, I think it's a critical component for DevSecOps. So we have no drift between environments. No human should go and connect to production environment and patch stuff and update stuff and drift from code. The code should be a source of truth. Everything is in Git. That's how we do our change management. That's how we enforce that people don't bypass the pipeline and go make changes in production. That enables us to instantiate environment on demand and tear it down every night if we want to, and bring it back up on different classification levels, replicate it, and segment it as needed. It's immutable, it's replicable, it's automated. It reduces the attack surface by not allowing people in production, disabling SSH, no ports open. We use the GitOps mechanism, which is kind of an evolution of IAC, where Git is the source of truth, but now instead of pushing from Jenkins or your GitLab CI tools to production or to staging, it's a pull. So your Kubernetes cluster will pull from Git. So in effect, you don't have ports open in your production or staging environment. Your production cluster or staging cluster is pulling from Git. And so in effect, the CI/CD tools do not have any access to your production environment. And so you get to have everything as code, networking, configurations, seal secrets. Everything is consistent. You can roll back if you have an issue. You have full continuous monitoring of the changes. You can do multi-party signing. So if you have things you want to have multiple set of eyes to approve a change, you could do a merge request with 3 people approving it, or 2 people approving it, or 1. And so then you control change, and your change management becomes a bunch of merge requests or pull requests. And then in terms of disaster recovery, everything is code. So all you have to back up is your Git repo and your databases, and you have a full replica of your environment. Much easier to instantiate with complete automation, and everything becomes declarative, and manifests and playbooks describes the desired state in code. And so by just reading the source code, you end up being able to know exactly what should be running in production, which creates a great concept of comparing your source code and comparing what's running in production. And if there's a drift, or if there's something running in production that's not in code, there's either something malicious or something happened that should not have happened. And you can then take action to prevent that. And that gives us tons of ability for continuous monitoring to know what's going on in real time. We use Argo CD on Platform One to be able to do that pull from Git. Argo CD is able to segment repos, so we can have different teams with different access on Kubernetes. So you could have a service mesh team that does the whitelisting of traffic for container A to talk to B, is a different team than container A can only deploy the container for in one Kubernetes namespace, for example. And so you have the concept of need to know, least privilege, separation of duties by segmenting your Git repos and who has access to what. Okay, so a lot of people ask us again, what is a continuous ATO? We are defining this with a DSOG and creating a continuous ATO guidance for the authorizing officials, for the SCAs and ISSMs and the cyber teams across DoD. It's very different from a fast-track accelerated ATO. The concept is compliant with the DoD Enterprise DevSecOps reference design. If you have not seen that, you should take a look at it. That's how we define how to spin up a DevSecOps compliant stacks with the baked-in cyber stack there. And so the concept of the continuous ATO is about creating the process, the CI/CD pipeline with the mandated testing, security, and change management gates that are able to enforce some of the gates that AOs would want to see to approve software. And you can have different thresholds within these gates. For example, you could say for a weapon system, test coverage of unit testing should be 100% or 90% or 95%. But then, for a business system, maybe 70% is enough of test coverage. But then same concept for static dynamic codices, bill of material, continuous security findings, CVs. What do you allow, what you not allow, and needs a waiver or needs approval to pass the pipeline if you have no fix, or if there's no way to mitigate some of the findings, or if it's a false positives, which is often common with some of these container security tools. So in effect, you validate the gates that accredits the platform. The software factory, in effect, is accredited to produce software, and what comes out of the factory is accredited. And then we authorize the teams, the people that will be using the factory. So people that come on platform one, for example, have to go through the onboarding training to be authorized to use the platform, and then benefit from the reciprocity and can deploy software across classification levels and have access to the CATO DoD-wide. And we don't have to go and revalidate findings across environments and across silos within DoD. So I have a bunch of backup slides. I know we have more time. I kind of went a little fast here. Maybe what could be interesting, we have Kevin Lantrup here from Capital Factory. He is the VP in charge of defense innovation. And maybe, Kevin, I don't know what you think, but maybe we could potentially take some questions now, and potentially I have backup slides where I can do deeper dives to take a look at different things. So are you going to read the questions, or am I reading the questions?
Yeah, I'll read the questions for you. We've got a few in the chat, and there's a few that I've wanted to ask you myself. So for starters, there was a lot of buzz yesterday and today around the Army Futures Command's announcement of their software factory. And I'd ask, what are 2 or 3 points of advice that you would give AFC as they stand up the software factory, learning the lessons from launching and running, Kessel Run and Level Up over the last couple of years?
Yeah, I think there are a lot of different things that come into play to have a successful team there. Of course, the culture, I think they're addressing very well, being located where they're located. They're going to have access to talent. They're going to have access to the industry and academia to be able to bring the right perspectives when it comes to making decisions. I think the number one lesson learned is don't get locked in, and don't just use a single company to guide you through that process. You want to have different opinions, different ideas. You never want to have just one. So Platform One, for example, has 8 or 9 different companies embedded into the team to bring us different perspectives. So we never just rely on one technology, and so that's a prime component of the success. I would also recommend the Army to take a look at what Platform One is doing and try to reuse as much of the code and the technology and the containers that we accredited. No need to reinvent the wheel there. I know they're tracking that. The key is, of course, to make sure we can do this at scale and have a two-way street between the repos. So if they have new capabilities that could benefit the DoD, it's a great way to share. That's what we've done with Kessel Run. That's what we've done with Kobayashi Maru, Space Camp, Ski Camp, Level Up. We have dozens of factories across the Air Force now. I think we have 20 plus teams. And so, I think the critical piece for me would be to really keep that in mind, not reinventing the wheel. I'm going to put the map of the names of the factory if you want to see that on the screen. But that is showing kind of the list of different teams using Platform One today.
Awesome. So I think there's an interesting parallel there, with Level 1 or Level Up being down in San Antonio, the Army Software Factory being up in Austin. Those two towns are super close together, but one of the things that we see a lot is that there's still that 77 miles up I-35 is sometimes an insurmountable distance when it comes to collaboration. So hopefully you guys can learn something about that and teach us how to bring those two ecosystems closer together. So there's another question you went over. You covered a ton of information, by the way, which was awesome. I would actually like to take a little bit of a deeper dive. A question that we get a lot relates to things like ATO and FedRAMP. And so you talked about CATO and continuous ATO. We had a question from Scott Schneider. How does Platform One facilitate ATO, continuous ATO? What does that mean for the companies working with you? I would add to that, what does an ATO even mean? How does it relate to FedRAMP? And does it have anything to do with CMMC?
Yeah, it's a great question. So, first, back to FedRAMP, right? If you go as a company and you spend the time and money to be FedRAMP authorized, and you have different levels from moderate to high and even lower than that. But for DoD, anything under moderate brings no value, and really high is kind of really the minimum to get to N-class data. And again, people have to realize for DoD meaningful mission use cases, we need to be able to bring the same capability on classified clouds. And by definition, FedRAMP is not going to enable that. So in effect, we don't see FedRAMP as a viable option when it comes to bringing services into the DoD at scale for real mission weapon stuff, right? So what comes out of that is the concept of containers. So by having a platform that can run like Kubernetes, that can run containers, we can accredit these Lego blocks, these capabilities, and companies can give us their container. So the same capability that they would have gone through FedRAMP and get accredited on the cloud, they can give it to us as a container or a bunch of containers. And we can accredit the containers DoD-wide and with full reciprocity all the way to SAP. So in effect, it's a 2 to 4 weeks accreditation time frame. We scan the containers. We have a whole onboarding guide on the website to have companies follow that process to be added to the repo, in effect becoming part of the marketplace. So as a company, you deliver your container to the repo, you get scanned, and you have to provide justifications as far as cyber findings. It's a very quick pace if you know what you're doing and your dependencies and what you're using in your software. And then we kind of provide a certificate to field. A certificate to field is what is used to deploy these containers into an accredited Kubernetes environment. And so then anyone across DoD running Kubernetes will be able to spin up at any classification levels the containers, in effect, making your product ready to go for DoD consumption at scale. And then we have the contract vehicle, the Devsecops contract vehicle. So these teams can buy your licenses and your services to be able to support or maintain or just have the licenses of the tools to be able to do that fast as well.
That's great. So I'd like to go back to, I think it was your slide 16, which discussed the broad agency announcement or the BAAs that you guys had. And so broad question, are there going to be any open or upcoming opportunities for companies who want to provide, as an example, DevOps, DevSecOps services? One of our portfolio companies, just as an example, Coder.com, has a really interesting approach. So how could they get involved, or other companies like them? Are there still opportunities?
Yeah, absolutely. So honestly, the virus kind of impacted that. We usually do this as an open, forum. People come and pitch their services and offering. And as you can imagine, with the virus, it kind of disrupted. We were supposed to do one in June. We're trying to do this either July, August for our next onboarding, and we will definitely have one. The question is it going to be fully virtual or not? This is obviously disrupting everything we know. What I also recommend companies in the meantime is to potentially become a sub of one of the companies approved. That's a very easy thing. There's nothing limiting the existing companies to not be able to add more products, more services. And so at the end of the day, we find that most people, there's 55 companies on the BOAS today. Very easy to find at least one that's going to be willing to add you to their portfolio. And so that's probably the easiest way to get this done in a matter of days and not wait for the next onboarding event.
Awesome. You mentioned something previously about massive scale training and training up to 100,000 people using automated content, something like that. Could you go a little deeper into that? Who's the audience that you're training? Is this for folks that want to work from the private sector that want to work with you guys? Is this for people within the services that are actually writing code? How does that work?
Yeah, so it's both contractors on DoD contracts, and it's also civilian and military people. We have kind of different trainings. So under 100,000 is the total number of people we're going to be training, but we have both the technical piece, which is a tiny subset. I would say probably 25 to 35,000 people are going to get the more deeper technical training on, why does cutting a monolithic application to microservices matter, why being modular matter, why test-driven development matters, cloud native, Kubernetes containers, all that kind of stuff, service mesh. And then you have the other side of the broader vision culture side, which is more for acquisition people, architects, PMs that have to understand why we're doing this, the benefit to the government of getting access to source code, getting access to this continuous engineering mindset. Stop talking about sustainment. There's no sustainment in software, it's continuous engineering. And so changing the mindset of the acquisition community when it comes to software and understanding the Devsecops model is the only way to build software in 2020.
Awesome. So we have a fairly specific question from Scott Schneider. When do you expect container support for the Azure tech stack?
So technically speaking, we can run on Azure today. We have engagements that are running Kubernetes on Azure. What we're doing now in the next 60 days on Platform One specifically is partnering with Microsoft and the different Kubernetes distributions. Keep in mind, we do not control when OpenShift or TKG or Rancher is able to support Azure government. And keep in mind, there's differences between the commercial public clouds and the government clouds. And so, that's been an impediment, of course, for some of these companies to get their stack running on Azure government or Amazon GovCloud. Air gap clouds, of course, for secret NTS is even harder. And so we're working directly with the companies. We have OpenShift on Azure. People are deploying Convoy and D2IQ Convoy and Rancher as well. I know VMware is also working on Azure. Honestly, it's driven by demand. One of the big reasons as to why more programs are using Amazon today is because of the TS cloud being on Amazon stack and not yet Azure. And I know Azure and Oracle are deploying a TS capability pretty soon. So that's going to help, because most of the work we end up doing is at the higher classification levels, and we need a way to push the containers to the high side. And so it does make sense to use Diode today for that, for example. And that's why a lot of programs want parity and the same stack across all the classification levels. So I would say within 60 days, Platform One will have an Azure unclass capability, and then following with Azure Secret. And then hopefully when they release the TS cloud, we'll have that as well.
Awesome. Well, it sounds like exciting developments. So we got another question from Mike Ziza, but I want to put that question in a little bit of context. So you are the first software officer for the Air Force. You are pretty open in social media about your background, your educational background, how you came into this job. And so I'm curious to hear your perspective on the story of why does the Air Force have a chief software officer? How did you end up becoming that? Do you have a counterpart in the Army? Is this a model that the other services should be following?
Yeah, I think it's funny how even my own opinion changed on that. When I started, and first I started at OSD ANS, and I was building this DevSecOps initiative with the ODCIO, and we had such a success, we wanted to find a home for it, and we thought having a service as executive agent would make more sense. And Dr. Roper has been a visionary when it comes to DevOps with Kesarun and other engagements. So we thought, hey, creating something in the Air Force to still represent all of DoD, and that was a condition for me to even take the job, was to still provide all this to all of DoD. I don't want to start adding silos within the department. I was a little concerned by the title because I told them one thing I want is to do everything like the commercial side, and there's no chief software officer on the commercial side. And so, but we also have different conditions, and the size of the organization is very different. In effect, enterprise services for DevSecOps is critical, and we find CIOs and CTOs to be struggling, even on the commercial side, to understand what it takes to take and build an environment with a cybersecurity, zero trust, the DevSecOps piece, the containers, the Kubernetes piece, and bring that as a cohesive multi-tenant capability, enterprise scale capability for their own teams to consume in a large organization. And we see dozens of commercial companies starting to reach out to ask, hey, how do you do this? Do you think we should have a CSO? And I heard that several companies are starting to hire or try to find the right person to bring to the table to do this. And it's tough because there's a culture piece, there's really understanding the vision on long term of software, and there's a very deep technical background that I guess I have to even understand, the concept behind Kubernetes and service mesh and all that kind of stuff. So I think now that I see the results of enterprise services and how complex this is, I do agree that it does take maybe a dedicated role to get there. The question now is, where does the role reports to? If I were to report to a CIO, I think it would have been very inefficient because I would have to wait for funding and you wait a couple of years just to do anything. The fact that I'm on the acquisition side and reporting to Dr. Roper directly enables us to use program funding to get things done very quickly. So I love that model. I think not many organizations would be able to do what we've done in a year, and so really the right reporting structure and funding stream is critical, but also having the mindset of kind of an entrepreneur with my background, where I see Platform One as a company that has customers, and we want to provide a service, and they can use as much or as little as they want. And if you don't have customers, you should not exist. You're not mandating stuff. You're not pushing people to use the capability if they don't want to use it. And the fear is sometimes in the government or even in commercial companies, people build enterprise services that are one size fits all, very limited. We wanted to bring a ton of options on Platform One. We have dozens of containers, distributions, really a lot of different things that people can customize to adjust to their mission, even more when you're dealing with all of DoD with so disparate set of needs and mission. So I think really keeping that in mind, and the fact that I guess my background is on the commercial side is creating companies, really helps me to keep the same mindset here.
That's awesome. So you as has been the case throughout this 40 minutes, have just said a whole ton in that. I'll just highlight a couple of things. One is, I think one of the innovations that the Air Force has really led in, as the DoD stands up all of these various innovation cells, is I see consistently throughout the process contracting and acquisitions being embedded within the innovation cells. And I think that even our partners from some of the other organizations would agree that the lack of embedded contracting support has been a little bit of a hindrance in being able to execute at speed. And so I think that that's a really astute point. Another thing I'll take out as a follow-up from what you just said is, so I think it's really cool that you said that there's not really an equivalent position within the commercial space to kind of what you're doing right now. And do I understand you correctly that the commercial industry is going to follow the Air Force's lead in establishing a chief software officer position as something to manage enterprise DevSecOps services?
Yeah, so I have several companies reach out, from banking industry to healthcare to retail, you name it, a lot, because we open source the entire stack. That's also a big achievement in DoD, right? To go and say, hey, everything we're going to do is going to be open source, and we're going to benefit from the community. And obfuscation is not bringing any type of security. It's a false sense of security, and we want to bring real, tangible security. And so we open source the whole stack. So we get a lot of companies to reach out and have a two-way street, and even want to participate in some of the code and products we're building. And so, yeah, I hear even some defense industrial base primes large primes looking to get a CSO to start having an enterprise DevSecOps team, because they also realize that each program is coming asking for DevSecOps capabilities, and then end up reinventing the wheel at every program layer, which is highly inefficient. They want to save money. They want to be more efficient. They also want to retain talent. You know, the minute you can say, hey, we're contributing back to open source upstream projects, we're involved in the best technologies, open source technologies out there, these developers and designers and teams within the DIB are pretty excited to remain there instead of moving to a Google or Amazon or Azure or whatever, Microsoft, and really be able to continue working on the most innovative things while, you know, making a difference for their countries at the same time.
That's awesome. So I want to move on to cool names of innovation organizations. So you mentioned the party bus earlier, and I was a little bit confused by what you were presenting on that slide. So you mentioned that the paying users to get on that platform, $2K per user per month for a various level of classifications for developers. So could you dive into that? Who are those paying users? Is that other services that are effectively MIPRing money to be a part of what the Air Force has created, or is that again something that's for commercial industry to get involved with?
Yeah, it could be any of the above. So it could be a program office like F-35, Jake, or, you know, whatever program, you name it, that is trying to move to DevSecOps, and they don't want to build a factory. They don't want to have all this headache of building a pipeline. They can just use the party bus, right? So smaller teams love to do that, right? When they don't have all the resources to build a custom environment, they can go to the party bus. They can get access in a day or a week and really get started, get the training, onboarding to get started. Both for their contractor or civilian military personnel, doesn't matter. The cost is per user, per developer. So they get access to the environment, and they get the CATO, they get the ops, they get the tools, they get the cloud, they get turnkey access to all of that, which, you know, one might think it's expensive, but when you start adding costs of ops and cyber 24/7 support, if you have to build all that stuff and get all this done at production layer as well. It's not just a dev environment, it's a dev, test, staging, and prod at multiple classification levels. It's actually a bargain. You end up saving millions if you were to do this yourself, which is why smaller teams don't have the funding to even do that. So they have no choice but to use something like that. And then the Big Bang is just a dedicated instance. So a bigger program like F-35, they don't want to share resources, or they want to pick tools on the CI/CD pipeline, for example. They don't want to, let's say they don't want to use some product, they want to use another product. The party bus, you don't get to pick your tool. We pick for the enterprise based on demand, versus the Big Bang, you get a dedicated instance. And that's both for the contractors that could use that to build a DoD software, or it could be a program office or a PEO.
Yeah, that sounds awesome. I mean, I'm thinking of organizations like JSOC's Global Analytics Platform. Matt Bonini was here talking about that a little bit yesterday in the Deloitte Operational Data Science panel, discussing kind of some of their, you know, both talent and infrastructure requirements. It sounds like it would be a great fit. So staying on the topic of cool names, really quick. So AFC hasn't named their software factory yet. You have any ideas?
I never get involved in names because it's a nightmare, and I named 12 companies, and that's enough. I did enough for a lifetime. If you look at the Platform One logo, obviously we do fun stuff, and you know, with Baby Yoda and other stuff. But you know, I think it's very critical to have the right name and stay away from acronyms. And I'm also trying to stay away from Star Wars and Star Trek. I think there's enough of that. So let's try to be a little bit more original, and let's try also not to infringe licenses.
Yeah, I mean, now that Chris Lynch is out of the government, all the Star Wars names have to head to that side of the fence. But no, that's a great point. I mean, the name it's part of the innovation culture, right? You have to have the right innovation culture if you want to attract the right talent. You have to have a good mission. You have to have a good operation or environment for them to operate in, but you have to have that innovation culture as well.
Yeah, and the key is to let the team pick the name. You know, I see too often, you know, general officers come up and pick the name. That's the number one mistake you could ever make if the team does not relate to the identity of the team. And I let completely the team design the logo and come up with both the pitch and the branding and the story behind it. We created the ones. It's funny how the ones started in the Air Force, Cloud One, Platform One, the Repo One, and I think we have 28 ones. That was not my intent. I created Cloud One first based on LinkedIn. We have a big presence on LinkedIn, and we had a vote, and someone came up with Cloud One, based on Air Force One, obviously. And so Cloud One, that was the first one, and then the secretary loved the ones, and so the second one was Platform One, and now I think we have 28 ones. That might be too many ones, but we have Device One, we have Repo One, we have so many ones, but that's good. I think it gives a sense of identity. It doesn't mean there's only a one size fits all, though. It just means it's unifying the efforts across the Air Force.
Yeah, no, that's awesome. And I love y'all's LinkedIn presence. I will admit that I've had a little bit of FOMO as I watch people open up their Platform One swag boxes that they've been getting over the last few weeks.
Yeah, pretty cool.
So
that's the kind of stuff that people don't think about, right? The kind of investment in marketing. It doesn't have to be significant, by the way. That stuff doesn't cost. People freak out about the box and they say, "Oh, it's a waste of taxpayer money." That's nonsense, right? I mean, that the cost of the box is insignificant compared to how much we pay everything else. And the fact that we can create this culture and retain talent, you wouldn't believe how much it costs the government, right, to train and retain talent. So any little thing like that costs like $20 is game changing for the culture and really getting people excited to remain. And you wouldn't believe how many people are trying to either leave their existing organization and come to Platform One, or get engaged or partner with Platform One because of things like that. They see the difference with people pushing the envelope when it comes to the marketing and branding.
Yeah. I'll make one more comment on that topic, and then we'll move on to the next question because we have a few stacking up. But I think that at the DoD enterprise level, we need to have a discussion about some of the more restrictive ethics rules relating to gifts and relating to clothing, T-shirts, food, and how that gels with operating in these innovation environments when you're trying to integrate effectively into the environment and attract and retain talent. But moving on to Trevor Smith's question from L3 Harris, to what extent does Devsecops AF groups help specify requirements for edge computing hardware? And he's talking about minimum hardware requirements, processors, memory storage to run cloud infrastructure at the edge.
So I have 12 teams as part of the DoD DSOG, the DoD Security Authorization Working Group for Devsecops. One of the team is specifically looking at both embedded system and edge use cases, including running Kubernetes and Istio and the containers on real-time OS, which is a whole subset of the work, which creates a lot of complexity when it comes to real-time OSs. When it comes to edge in general, the vision is to be able to have different form factor of hardware that can horizontally scale and connect to create bigger clusters, right? So in effect, what we're trying to do is have different form factors with blades, for example, that could have CPU, GPU storage, right? And then you can swap blades, add more blades, or add more racks horizontally, all the way from a backpack to a Humvee to Interjet to a bigger data center on-prem disconnected air gapped. I think few key components are keeping in mind the air gap is really a requirement. We need to be able to have a full control plane on premise and not have to connect or ping back. I mean, pinging is great if we can do it, but it shouldn't be a requirement. So being able to be fully air gap is really critical for us. And then the ability to horizontally scale is more important than the hardware and the specs. In effect, if you bring me a rack or a tiny box that I have, some CPU, GPUs, and storage or whatever, and I can swap or I can tie two together, or three, and create a bigger cluster. And we're working with companies like Red Hat and VMware and others to see how do we automate the growth of the detection of, hey, you plug two devices and now you have a bigger cluster. It's detecting you have more nodes, you have more CPU, you have more storage capability, and now you can do more stuff without having to do anything in software, just by plugging the stuff. And so that's more the modular approach, instead of saying, hey, I want this hardware that is this specific set of requirements. I like modularity, and I like to be able to connect them to create bigger edge concepts.
Yeah, I mean, the modularity is key. The plug and play is key. General Murray was talking about this yesterday during the opening keynote. with Andy Jassy talking about, one of the big initiatives for the Army is and really across DoD is the modular open systems architecture and making sure that, things can be upgraded by really any vendor that can meet the security requirements and that can deliver capability. So a question from David Soul asking, is SAAR handled by Platform One, or is that the responsibility of the container owner?
Can you tell me what, sorry, too many acronyms in DoD. What is SAAR, do you know?
Actually, I do not know. So maybe we'll go on and see if
so maybe someone can tell us, and then I'll get back to it. Too many acronyms. I'm sure I know what it is, but until someone tells me what it is, I don't know.
So I have a question that you may have a perspective on, and I don't know how familiar you are with how the Air Force and specifically AFWERX is running the SBIR program. But this is something near and dear to a lot of our companies, which is trying to find that end user customer, two people, the end user and the customer for their products, and so that they can get onto that phase two. And Platform One has been, as the place where the application sits, has been a signer of a lot of MOUs, but I know we're moving on from that. And so what's the advice for you? How does that person connect, to the customer who might be using, whatever's going to sit in that API layer? And do you think it's better, should Platform One be a pathway for folks to find those end users?
So there's two components there, right? There's the ability for the company to demonstrate the product in a DoD environment. And I think being able to use Platform One to deploy the stack and do continuous iteration and continuous engineering live and not wait, a year or whatever, or 6 months to start getting a full accreditation of the product, it makes sense. So use Platform One as a development environment to also then get access to end user so they can play with stuff, right? I see organizations interested to try new things, but when they have to do the ATO and they have to spend a year to document the stuff, they lose patience. So just being able to be on Platform One, and ABMS picked Platform One as their platform, and so ABMS will be doing a lot of onboarding of different capabilities. So being able to be on Platform One just streamlines access to the end user so they can consume the service, right? So now it's easier to remove the barrier to entry, right, for these products to be consumed. Now, of course, it doesn't find you the customer, but at least there's no more barrier for them to start trying, whether it's just a trial, whether it's just a pilot or Pathfinder. But then, the contract vehicle of Platform One also gets you access to buying the product, or like you said, doing a phase two. But again, you could also sell the license. I mean, nothing stops you from then licensing the product as well with a vehicle. So you don't have to wait for a phase two. You could license the product and just sell it. I think the finding the right customer is very difficult. We try to help when we can. It is still very much based on relationship and who I know the team knows that could want to try something like this. We try to pinpoint people and do introductions. We do it all the time, but it's very inefficient. I mean, it's still driven based on relationships and what I know, what the teams know that someone is looking for. And so it's just very inefficient. So we're going to have the marketplace, and hopefully by being on the marketplace, then it's much easier for people to find out. So we're going to have tagging capabilities and categories of products. And then, assuming you have a good product, people will be able to find you already there, and you're already accredited, you're on a contract vehicle. That removes the barrier to entry. And now we can, really promote on everywhere in the Air Force this marketplace, and it's a DoD marketplace, so anyone can use it. So I think the marketplace could really help do the bridge between the customers and the products.
Awesome. So I think we're in our last minute. So Nick, I want to say thank you. I'm going to ask you to speak one more time, which is, so we've got investors, startups, academia, traditional defense industry, and other DoD programs and customers on the line. What's your call to action? What can this consolidated group that really wants to be helpful do that we're not doing to help you?
I think it's all about working together on this. Join the repo, share your containers, share your code. Don't fork the code. Don't recreate the wheel. Partner. If it's nothing is perfect. This is 6 months old. We know there's plenty of things we want to improve. Tell us what we can improve. Collaborate. Send code to us. Do merge requests. Join the AMA sessions. We have one tomorrow at 1 p.m. where people can ask questions for 2 hours directly to me. We're going to show tomorrow how we put Kubernetes on real time, on jets and bombers. So join, participate in those collaboration, and share and spread the knowledge. Everything is public on the website, so there's just no excuse not to have access to the content.
Awesome. Well, Nick, this is your first time at Capital Factory. Thank you so much. We're going to get you here in the flesh here, hopefully as soon as possible. But I really appreciate you joining us today.
Thank you for having me.
And now I think we're going to go over to Julie.
Hi. Well, thank you both, Nick and Kevin, and everyone who threw those questions in the chat. That was really engaging. Thank you. It's lunchtime, folks, and that means networking, not food. Pop over to the Hop In and start chatting. You will be randomly matched with other people for a little conversation and introduction. But don't forget to be back here at 12:15. We have another panel on Cloud to Edge by AWS. See you then.
from being spun, hung on every word, yeah, every single one. So this is not for na-na, promise to say you na-na-na. Have all bad days, oh na-na-na. I'm hard to love, oh na-na-na. God knows I need you, oh na-na-na. And when push comes to shove, forever is never enough. When I'm with you and don't fall apart, you make me feel like I have a high. Your beauty is my gift tonight. I don't wanna go another night. And when push comes to shove, forever is never enough. So this is my phone, na 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 phone, na 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 na. Slow, automatic, from a movie, cinematic. Your beauty is my kryptonite, and I don't want to go. So listen, I'm going na-na-na. Promise to say you na-na-na. We have a madness, oh na-na-na. I'm hard to love, oh na-na-na. I never thought I'd find someone. God knows I need you, oh na-na-na. And when push comes to shove, forever is never enough. When I'm with you, I don't fall apart. You make me feel like I have a high. Your beauty is my kryptonite. I don't wanna go another night. When push comes to shove, forever is never enough. We're gonna together, don't let them tear us apart. We've come through life, got it hard, and we just need one restart. Just tell me you love me, tell me you love me. Forever is never enough. Just tell me you love me, tell you you love me. Forever never enough. Oh na 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 na. Oh na 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 push me away, your lifeline, losing your mind. I'm here for you, babe. I've loved you the same this whole time. So tell me, what's on your mind? And I'm not.
Well, welcome back. You just heard from Nick about how developers should best ensure that what they develop is as secure as possible. Yesterday, in the keynote with General Murray and Andy Jassy, you heard about how AWS is securely extending the cloud all the way to the edge and providing the tools that enable its partners and customers to build solutions closer to the mission. Now, you're going to hear a little more detail on these services that will allow builders to design, develop, and deploy solutions at the edge. Before we bring on Shane Hawthorne, the AWS Aerospace and Satellite Solutions Space Technology Leader, to talk about how to use AWS services and AWS Ground Station to provide data to disconnected warfighters, we need to bring on Evan Glemstad to talk about how AWS is redefining the edge. Evan? Hi.
Hi, everyone. So I'd like to talk to you a little bit today about how we are redefining the edge with AWS. My name is Evan Glemstad, and I'm the head of business development here at AWS Worldwide Public Sectors for edge computing. I want to talk to you today about services like Outpost, Wavelength, Local Zones, and the Snow family. Some of this might be unknown names to some of you, or it might be familiar names. But first of all, what is edge computing and what can it enable? Well, it's all about bringing the capabilities of AWS closer to the users, closer to other systems that they might be integrated with, so that you can transform legacy environments, legacy infrastructure, and come up with new use cases or novel use cases that weren't possible before without having this infrastructure available. So the whole idea here is to be able to develop once and deploy anywhere, not just in the region, but in customer data centers, in forward bases, on Humvees, on boats, in UAVs, whatever it is, you should be able to develop once and deploy anywhere. So I'm going to go through a few of our services, and this first slide might be a little bit overwhelming, but don't worry. As I say, stay calm. I'm going to go all through this in systematic fashion and take you through all this and how we can cover all of these services and use cases basically anywhere in the world. So what we're going to do is we're going to look at this from the outside in. So from the furthest edge, I mean, we're talking disconnected. It could be in a desert. It could be hovering underneath a UAV. And we're going to start really at the far end and then work our way inwards. So the furthest edge here is really the Snow family. And the Snow family consists of a lot of different services or a lot of different infrastructure that can operate in disconnected environments, in harsh environments. And we just brought out a new device here as well that I want to talk a little bit extra about. So first of all, the Snow family is used for two main use cases. One is about data migration. So let's say you need to move a lot of data from point A to point B, and you want to move it into the cloud, for example, from a customer data center or from other places where you're capturing all this data. But you might not have the connectivity to do so. Or you have a connectivity, but you're using it for other things. You don't really want to load it with you moving all this data. So what you can do there is you can use our devices like Snowball Edge and Snowcone and some of the other ones to move this data in an offline fashion. The other use case for the Snow family is edge computing. So the challenge here could be that you have no connectivity, or there's a very low connectivity, high latency, sporadic connectivity, or it could be a very harsh environment, like in the desert, or on a ship, for example, or in a boat. There's a lot of different use cases here as well, where you need to have some kind of edge computing. You need to have compute closer to where the data is captured and do something with the data straight away. But it's definitely outside a normal data center environment. So some of the places where we do see edge computing used quite a bit is some of these areas. So anything from content distribution, you need to get it out to a lot of different sites, for example, from the cloud. It's obviously a tactical edge. IoT, industrial and healthcare, field hospitals, transportation, logistics, autonomous vehicles. All these are places where we see a lot of edge computing needs and where the Snow family comes in. I just thought I'd talk a little bit about a few use cases that our customers are using Snow for, just to give you a little bit of background on what it can be used for. So one of our customers, Philips, are using Snow to support their medical devices or medical machines in hospitals. They need to have some kind of capability close to these devices to capture the data and maybe do some initial analysis on the images that are captured and to allow doctors to work with this data. Now, they could just use legacy hardware for this, but when you're scaling this into thousands of various different locations, you need to have a repeatable way that you can deploy this with things that you've developed in the cloud or you developed through a POC, and then you want to deploy to a lot of different locations. And that's what the Snow family allowed them to do, where they can order a Snow Goal Edge, for example. I'll get back to what that is. And get it shipped directly to the hospital or the location where it's needed, preloaded with the software that's going to run on top, and ready to capture data, and then allow the physician, for example, to work with this data through their systems. Another use case is for the NGA. They're using it as part of Odyssey to do some analysis. Here's used more in a clustered facility as well, where we can tie several of these together, both for latency, capacity, and for fault tolerance. I'll come back a little bit more to that as well, but that's one of the ways you can do it. Capture data, do some analysis on it. Here you're doing quite heavy analysis on it, and that's where it can be tied together. Nevada, on the other hand, are using it in that disaster response and IoT in new builds, houses, for example, to capture sensor data and do analysis on that in environments where you would not necessarily normally deploy computing capacity, or you'd have to find some way of doing that. That's where it's very easy to just deploy a Snowball Edge and do the processing. DIRT, as part of Help NGO, was another time where we deployed Snowball Edge. You can see a little bit of the size of the Snowball Edge there in the middle, at the bottom in the picture. But it was used for capturing images and everything around that when Hurricane Dorian, Category 5 storm, hit the Bahamas in September of last year. They were engaged to help the humanitarian response activities, capture data, and do some analysis on that, and then transport that into the cloud. Obviously, connectivity is not easy in a disaster response scenario, and you have to ship these devices. You have to hand them off, transport them through some kind of logistical channels. So that's where Snowball Edge worked out well. So the Snow family, as I said, it consisted up to a couple of weeks ago of Snowball Edge, which comes in two flavors. I'll get back to that. It's about the size of a large desktop tower, certified for single person carry. It's 150 pounds. And then you have Snowmobile, which is basically a big truck full of hard drives, to simplify it. They say don't underestimate the bandwidth and the capacity of a truck full of hard drives hurling at highway speeds to the nearest AWS data center. It could actually be faster than transferring the data online when you're talking about transferring massive amounts of data. So that's a capability we have there as well. As I said, Snowball Edge, which is definitely the more deployed version of the Snow family, comes in two different flavors. So you got a compute optimized flavor and a storage optimized flavor. The compute optimized has more compute capacity, less storage. But if you're doing some kind of analysis out there that you need some heavy churn on, you need to work through that data and maybe respond to that straight away, that might be a good solution for that. It can also come with a GPU. So if you have machine learning applications that are working on analysis of video or images, for example, that could also be a good choice there to do that before you send it to the cloud. So you do the initial analysis out there, just churn it, and then instead of sending all the raw data up to the cloud, you only send the results and what you're really looking for. Storage optimized, on the other hand, has more storage capacity. Not as much compute, but there's still compute capacity there. So that's for slightly different use cases where you need to ingest a lot of data, for example. And then I said clustering. Clustering, if you need to tie together to have even more capabilities than what you can with a single Snowball Edge, you can tie them together and create larger clusters. But what I'm most excited about is actually our newest member of the Snow family, which is called Snowcone. You might have seen this over the last couple of weeks. We just launched it. It's got the same military-grade security. It's tested for harsh environments. You can do online or you can do offline data transfers. It does have some compute on here as well, so it could do some basic initial analysis, for example, of data, or to help run some services on the Snow device itself. So it's not just like a NAS, it's not just a little hard drive that you can send out to someone. It is definitely a fully capable solution that you can deploy AMIs and other services on that you've tested in the cloud, for example. It's very easy to develop that in the cloud, deploy it on one of these, and you could literally order 1,000 of them to 1,000 different addresses, and it would be shipped out ready to go. The size of these are about the size of a large tissue box. It's less than 5 pounds. It's easy for backpack carry as well. And because of this, it enables usage of AWS services in more locations than it's been possible so far. In one of the videos that you can see from the launch as well, I think it's also on YouTube, we strapped one of these to the other side of a UAV. And by doing that, we could fly around and collect data and do analysis of it straight away. Because it's also got Wi-Fi, you can transmit that data back even while it's collecting data and doing analysis. So that kind of takes care of the far edge, the Snow part of things. Like where these are the bad areas to operate in from a technology standpoint. They're not easy. It's often disconnected. And it's unreliable connectivity. But you need to have some applications out there. And along with our theory of develop once, deploy anywhere, that's what enables you to deploy in those kinds of locations. But let's say you do have a data center and you want to deploy more capabilities. You need something that's stronger. That's where Outpost comes in. So Outpost is designed to go into existing data centers in a forward base, for example, if it's more established, and it is an extension of the region of what we call AWS proper out into your data center. So Outposts is the same AWS design infrastructure. It's basically everything AWS, same APIs, same management console, same infrastructure that you would find in the region, and therefore you can manage it in exactly the same way. You can deploy things in exactly the same way that you did in the cloud. There's complete parity there. So if you can deploy something in the region, you can deploy it on an outpost as a EC2, which is our virtual machines, and use EBS storage, for example. Some services are consumed locally on the outpost itself, while others are consumed from the cloud as well. And we can also tie several of these together. It's also a fully managed service. It's not a product. And the way I describe that is that a fully managed service comes with people. It comes with operations, dashboards, and more importantly, it comes with alarms. So that if something happens that's unexpected, people get paged, and then they can do something with it so that they can restore the capabilities fully, and you can just keep using it. It's kind of the same way that you would do with the cloud itself or the region, in that when you deploy something in the region, you don't really think about what's underneath. You don't have to think about that, because that's our job to make sure it runs. It's the same thing with outposts. You don't have to run an outpost. That's our job. We got to make sure that's available to you as capacity, and then you can just deploy whatever you need on top. The other thing is, as I said, it's a single pane of glass or a single pane of management for both this and whatever is running in the region. So that means the same people that are managing your AWS deployments can also manage the outpost without any extra learning curve or anything extra around that. So what is the outpost? Well, it's fully assembled racks. It's one or several, and they either are custom made or based on standardized SKUs that are available on our website. It's so that you can also chain several of these together into one logical outpost, and thereby get even more capacity to deploy things. As I said, they're fully assembled. We literally just roll them into your data center and connect them to power and networking, work with your people there, and then we make it available in your AWS accounts. Everything is obviously redundant, and it's designed for always on, always connected. Some of the use cases that we see most for Outpost is low latency. That's one of the general ones where for some reason you need to have something process things very quickly. It needs to be tightly coupled with other systems, and bringing that data all the way to the cloud and back again might actually be just too far. Local data processing is another one. If you're ingesting large amounts of data in a data center environment or integrated with Snow devices, for example, I'll get back to that. But if you're doing that kind of initial processing in your data center, you need to ingest a lot of data, do machine learning on it, or do some kind of other analysis before you send it to the cloud. That's where Outpost comes in. Another challenge that we've seen is with data residency. So in areas where we don't have regions and customers want to deploy some of our services, then it doesn't have to be either just a country, it could be a state, or it could be some other kind of restriction that says you have to keep data in a certain area. Outpost can be used for that. There is a little starter, a caveat, because the metadata does go back to the region, whether that region is somewhere like US East 1, like North Virginia, or it could be GovCloud for that matter, or any of our special regions. A couple of extra ones that we see quite a bit in public sector specifically is migration acceleration, where a customer is looking to move to the cloud, maybe over the longer term, but making that jump for especially tightly coupled applications where you have many different services working together on the same data, it just might become too much of an effort to move everything in one go. And they want to be able to have a way to move a little by a little. Now, instead of them trying to figure out how do we transfer this data back and forth all the time, you deploy an outpost and you start moving the applications over to the outpost. That way, if you choose at some point in the future to move that to the cloud, you can then pretty much just flick a switch and you can run in the cloud instead, or scale to the cloud for that matter. If you want to run things on premises and then scale under heavy usage to the cloud as well, to use that as a backup or a disaster recovery scenario. The last one is something that I affectionately call small, medium, big brain. It's about the integrated edge, where we're taking several of these services and using them together. We see this desire now from customers, and they started developing solutions around it, where you could have something like snow cone on in a car, you could have it in a backpack. You're doing initial data collection all the way out there, or you're using it to collect data and do some analysis on it. You're responding to it there and then, but you want to capture that raw data as well. So you capture it on the snow cone or a snowball edge for that matter, and then you synchronize it with an outpost at a forward base, where you have much more capabilities. At that point, you can do even heavier analysis on it, whether it's machine learning analysis. There's GPUs available there as well, and you can scale it much larger, which means you can do much deeper analysis on it. However, it does also have its limitations. So if you do that kind of cooperation, collaboration, synchronizing between the different snow devices there, and then transfer it up to the cloud, up to the full region, you can then have access to hundreds of thousands of cores that you could deploy at will to do very, very deep analysis and to do global cooperation. And that kind of builds together that full transition from the really far edge. You have someone running around with a backpack with a snow cone, synchronizing with a snowball edge on a Humvee, for example, then going to a base. You're offloading the data there to an outpost, do some more churning of the data, maybe do some recognition, and then you send it over to the cloud and the region, where you really do that long-term analysis, archiving, and storage, and cooperation, collaboration. The availability of outposts today it's in these countries. I'm not going to go through the full list, but I'm just showing you the map here of where we have the capability to deploy outposts today. This map is growing all the time. And just to mention that these can be hooked to the closest region, or it could be hooked to any other region as well, as long as it's within connectivity back to the mother region, so to speak, has a good reliable connectivity back and the latency isn't too long. It can be connected to any region within reach, not just the closest physical one. So that's just something I wanted to mention as well. The security aspect is always very, very important to us. One thing I wanted to mention with Outpost as well is because now it is, in a customer scenario, a customer-owned facility. Not saying that the security there is not as good as an AWS data center, but just because we don't own that security anymore, we wanted to create some more services around this and some more capabilities so that you can be sure that your data is fully secure on here. So there's obviously this tamper detection and things like that built into the hardware itself. All communication back to the region is always fully encrypted. But in addition, all the data on the Outpost itself is encrypted. And the way that this is handled is through what we call the Nitro framework. And the Nitro framework also includes a hardware key that is a part of every server that is deployed in an Outpost. So if for some reason that data needs to be shredded, or it needs, let's say it needs to be replaced and a new piece of hardware inserted in its place, this key will then be pulled out, and you can then take a screwdriver, put it on the bull's head in the back there. That sits over a screw that is on top of a microcontroller. The microcontroller holds the encryption key that holds the encryption key that encrypts the data that's stored on the Outpost. If you screw that in, the microcontroller shatters, and at that point, all that data is crypto shredded. It is unreadable from that point onwards. So we built that all the way into the Outpost itself, and that's also one of the reasons why we didn't bring out Outpost until now. Even though it's something we thought about for a long while, we wanted to make sure we could guarantee the same kind of levels of security that we could offer in the region itself. So quickly summarized, Outpost is there when you need low latency, you need data processing, you might need an integrated edge, and you want the same capabilities, the same infrastructure, the same APIs, the same controls as you would do in the region. You just need it in your data center or in your forward base, for example. That's where Outpost really comes in. So that took care of Outpost. Those I would say are probably the most fitting solutions right now for the kind of use cases that I understand that you're looking for. But I just want to mention as well local zones and wavelength. Local zones, first of all, is now we're getting even closer to the region. This is, I wouldn't call it a region light, but it is definitely about bringing some of the capabilities into other areas where we don't have a region today. Local zones is when you need very low latency access, so single-digit milliseconds, and it has to span a specific geographic area. And we don't have a region there, and you don't have a data center there, for example, or you don't want to have a data center there. That's when local zones comes into play. We only have one that we launched so far. It's in Los Angeles. And the idea here again is that it's the same controls, the same management data plane. Everything is the same as what you would see in the cloud and in the region. Again, the thought of develop once and deploy anywhere is what we're trying to enable. The question I get a lot is, when do we do local zones versus an outpost? The first thing is that local zones is shared capacity, kind of like in the region, while outpost is dedicated capacity. Outpost is yours, and you kind of control it, all the capacity. Local zones are hosted by us in locations we've contracted, while outposts are placed in your data center or colo facility or anywhere else that you have a data center like environment where we can deploy it. The third thing, and this is probably the most important, local zones are still large. They're not as large as a region, but they're still very large. So they're not suitable for short-term cases. It's usually something that we're looking at forward for larger deployments, larger countries, but it's not something that can be used for a short-term use case. So if the roadmap doesn't exist, or if it's something that we're not planning on right now, I mean, we're not rolling these out everywhere. This is something that's going to be very tactically deployed. Outpost is something that can be deployed anywhere in any of the countries that we were just talking about, and it's up to you where you want to put them. So that's something that can be done at will today. The last thing is obviously that the local zones are pay-as-you-go, while outposts are term contracts where the capacity is dedicated to you for a certain time period. Okay. If you're not confused yet, let's add on one more thing. I think this is something that also could be very relevant as we start rolling out this service, and it's for mobile clients, mobile devices, a lot of IoT, for example. We're trying again now to enable our builders to build things that can be deployed in telco networks as well, and 5G networks. Again, with the same kind of thought, build it once or develop it once and you can deploy it anywhere. Wavelength is basically about deploying it through 5G networks and other networks where we're trying to build the capabilities, or rather you're trying to build the capabilities of your application and your workloads into the telco network. That enables you to provide very low latency access for applications such as AR, VR, for example, to a lot of different users across a bigger geographical area or in various cities where wavelength is available. It provides the capacity where you can deploy applications directly into those networks. So we're trying to provide those applications, again, closer and closer to users and machines so that you can develop anything that needs ultra low latency access. Especially for things like augmented reality or AR. unless you have very low latency, it's not going to provide a good experience for the end customer. And that's one of the things that we're enabling with Wavelength. It's not generally available yet. We're working with partners across the globe to deploy this. And it's slated for sometimes later this year. Again, I just wanted to mention that it's the same infrastructure that we have in the region. It's hosted in a telco network. It's managed and monitored by us. So again, you just use the capacity. It's our job to make sure it's there. It's our job to make sure it runs and it's available to you at any time that you need it. And it's fully integrated into the networks so that you can enable those very low latency access applications. So that explains that entire image. I hope that makes it a little bit clearer. I know it's a lot of things to take in, a lot of different services, but we're definitely with this enabling you to build things that can be deployed anywhere outside the region as well, not just in the region, but to create that integrated picture all the way from the really far reaches, like the desert, in a backpack somewhere, through the data center, through mobile access and wavelength and 5G networks, all the way into the region, and enable that collaboration and joint analysis. So that's what I had today. As I said, my name is Evan Glumstad, and I'm very happy to meet you all today. I think at this point, Shane is taking over and is going to talk to you a little bit about ground station. Over to you, Shane.
Thanks, Evan. Well, good afternoon, everybody. My name is Shane Hawthorne from Amazon Web Services, and I'm coming to you from Colorado Springs, Colorado, and very happy to be a part of this great event. Thank you guys for having me. So I'm going to talk to you today about Amazon Web Services Ground Station. But first, I wanted to tell you as well about a new organization that we just launched and we're very proud of. Teresa Carlson announced it on 30 June. I have her blog down here on the bottom if you'd like to go look at it. And basically, we are putting together now the Aerospace and Satellite Solutions business area so that we can really focus all of our efforts in a single effort into space. And we want to bring all of our AWS services and solutions to you into the space enterprise, both in the public sector as well as in the commercial sector. And we want to help work with you, our customers and our partners, to reimagine space system architectures and how you would do them in a web services way, how we can then help you transform your space enterprises, and then help you launch new services that can process space data both on the Earth, both in hybrid architectures like Evan was just talking about, and up in orbit in hybrid architectures. And then finally, we want to give you all the services that you need to support government missions and commercial missions. So as a background on what I'm going to talk to you about today, AWS Ground Station came about because we realized, and a lot of our customers that we worked with initially to work backwards told us that cloud offers a lot of value to satellite operators and data that they weren't realizing. We were working with tons of different satellite companies and discovered that most of them were operating on AWS, but they weren't getting the full advantage of AWS, and we wanted to help make that better experience for them by giving them scalable data processing. So if you launch one satellite, like say you're a small sat experiment out of SMDC, or whether you're going to launch a whole constellation of vehicles like the Space Development Agency, you could just come into AWS and only pay for what you need and scalably process only what you need for one satellite or what you needed for 24 or 30 or even thousands. And then you could take advantage of our storage, our data analytics, our machine learning and AI, and use that now to develop your products, and then use AWS's great network to move that data around the world, and with Ground Station, even up into space, and disseminate that information to where you need it. And to help facilitate that, we built our AWS ground stations and co-located them with AWS data centers around the world so that they would offer unique architecture benefits to you, because by being right next to a data center and connected to it with the right kind of connectivity, you get very low latency services in the realm of seconds that you can get that information into the cloud and then immediately start using cloud services on that information and get products out to customers in seconds. So the value prop that I'd like you guys to think about would be, first off, with AWS Ground Station, you've got a global antenna network that's built on top of the security and infrastructure that AWS has put together for our entire regional construct and availability zones. And that's a great area for warfighters and the services like the Army, the Air Force, the Space Force to focus on, because those are the things that could benefit the government to be able to have this global network and all of this high security that you need to grow your architecture in a scalable way, but not have to pay for any of it, except for when you need the service, you actually come in and pay as a service and don't have to worry about it any other time. Then for the rest of the community, which is the contractors, the integrators, and our partners that are building the services and the applications that you need to support the warfighter, they now have access to the scalable ground processing, the network that we have, and our storage, as well as the great services like SageMaker, CloudFront, Content Delivery Networks, and Greengrass for AI and ML, so that they can use the cloud and our transparent pricing to deliver the things to the government that they need. And for both of those customer communities, you're now going to minimize the capital and the non-recurring expenses that you have to put into it. And you've got scalability so that with the one satellite system, you're only paying for what you needed for one satellite, and you can grow over time without having to change your ground architecture at all and only pay for what you use. So where are all these great antennas? We've been building, and right now we've got a ground station located in Oregon, very close to our government cloud in the west coast of the US. And then we've got our next ground station in the Ohio region, close to our eastern Gov Cloud. And then we've also got ground stations in Dublin, in Stockholm, in Bahrain, and in Sydney. And keep on checking our What's New blogs as this year goes by, because you'll see that we will be launching several other ground stations later this year in other parts of the AWS network. As you could see on the previous slide, those great systems are connected to a fiber network that connects all of AWS's regions and is managed by AWS. And the cool thing for our space customers is that now gives them what they really want to be able to build their mission and deliver data to the public and to the commercial sector customers. They've got elastic cloud compute, so you can actually start to convert your hardware modems and what they call in the satellite world to convert raw data into regular types of objects and information that people use, front-end processors. You could do all of that in the future on EC2, Elastic Cloud Compute. And we've actually been working with a number of vendors and customers so that they can get their products ready to operate in a virtual way on AWS. Next, you've got the ability to take advantage of our simple storage service, or S3, and all of our other mechanisms for storing data like Glacier, because in the satellite world, as many of you are probably familiar with, it's all about comparing data that you've had for years, decades even, with what you're collecting today, so that you can do change detection, you can find things that you didn't see before, you can compare the effects of disasters or environmental impacts from with what the environment looked like previously, and you can actually build a lot of great products. And so you store a lot of this data. So what better way to have that data accessible, but then put it in the cloud so that it's able to be moved anywhere in the world, or its products can be moved so that you don't have to move all that heavy data around to do your mission. Now you've got things like SageMaker and then AI and machine learning that we can help our customers use to automate the analysis of that data so that they're not having to look at that data and make decisions themselves. They're actually able to instead benefit from systems that can actually detect objects like swimming pools or building perimeters or town perimeters or bridges, and actually identify them, do before and after comparisons of data building on that stored information I told you about, and then bring forward to the decision maker things that they wanted to pay attention to, like bridges or objects or specific shapes, so that they can use that to help feed their data analytics and tip and cue with the rest of the mission that they're trying to get done. And then you have things like CloudFront, where you can actually distribute data very quickly and efficiently around the world to all of your users in a seamless way using AWS services. So now let's tie that together. I wanted to show you some cool things that would combine AWS Ground Station with some of the hybrid architecture approaches that Evan just got done talking to you about. And the first one I'd like to show you is where we're going to be talking about pushing warfighter data to the edge. Now, I'm going to slow down a little bit because I wanted to save time to be able to talk about these two examples in greater depth for you. So we're working with over 80 different customers now using AWS to help bring these types of products to their customers through AWS Ground Station and over AWS. So they're collecting Earth observation data in this example. And for this community, I figured let's put a TEL down there, something that can go out and transport missiles, erect them, and then launch them. Something that's quite often, an interesting object that folks like me and you from the military have been wanting to track. So we're out there, a system tracks that data and comes over an AWS Ground Station region and is able to now downlink that raw data to the AWS cloud. Now, a lot of people who want that information, if they're not like in the hardcore realm of analyzing intelligence data or looking at open source information to find things, they just want to know what is an object and where is it and what is it doing. Those types of things can really be condensed and built into a compact message format that can be distributed around the world. So you don't want to move all that data to the edge. You want to be able to just give the benefit of that data to the people that need it in a quick, easy to use way. So you bring that data down to AWS. You use the services that I told you about earlier, like EC2, to actually turn that raw data into a product that can be analyzed. Then you can actually automate and orchestrate this data processing flow to move it into an AI or machine learning algorithm that's going to basically identify things, bring them forward, try to give them a correlation to what type of an object it is, and then input that into something that could start making inferences like, okay, this is close to another customer, it's close to a warfighter. We want to alert them to that, and we want to send them basically an icon with a representation of what the information is and an automated guesstimate or estimate of what the object is. At that point, we would move it back out of the AWS cloud to a relay system of your choice, and you would be able to then move that data through a direct connect to an antenna, get it back up to the relay, and then the relay could send it down to the warfighter in an RF format that they're already used to using, and using a satellite system, for example, like Inmarsat, that you're already using to do operations around the world, so that you could distribute this information to the warfighter. In the old days, that would have taken a long time because you would have had to wait for this satellite system to get to its own ground stations, and then you'd have to wait for it to get moved to a processing area, looked at by an analyst, put into a messaging system, and then put up through the relay to your warfighters. In this case, you could actually automate it. The data could get from the downlink into the cloud in seconds. It could get processed in seconds or minutes, and then it could get moved in seconds again to the relay SATCOM Earth station and up to the relay and down to the warfighter. And now you can use, like I said, geo satellites. You could use medium Earth orbit satellites like O3b to get that data, or in the future, you could take advantage of the broadband internet satellite systems that are coming to distribute that data to the world in seconds or even milliseconds. Next, let me talk to you about what do you do, though, if you just wanted to be fully contained. You're kind of trying to stay low profile, and you don't want to be able to have a transponded signal that you have to depend on. Instead, you just want to be able to receive data and use it. In this case, building on what Evan talked to you about again, you've basically got a Humvee or some other vehicle towing an in-theater mobile X-band antenna. That same Earth observation satellite that I told you about earlier could instead now be commanded through AWS Ground Station to downlink data to your location. And it would be encrypted. It would be all the same types of processing that you would do in the cloud or at its own ground station. But instead, you have your own antenna, and you could take advantage of a snowball edge cluster to be processing on maybe the optional NVIDIA instances, or just on some of our typical compute instances. You could have a software-defined radio and a mechanism for moving that data into the cluster in a lossless way. And now you could do many of those functions that I just told you about in your Snowball Edge cluster, using the compute and the storage and then AI and ML types of algorithms to do the same type of analysis and then data dissemination. And then finally, you can now take advantage of carrying around a snow cone like Evan talked about in a backpack, or using your own concept-equipped radios to move that data around the area that you're in so that you can keep track of things, you can report threats, and you can keep people aware of what's going on. So in summary, by combining our hybrid architecture and many of the edge compute devices that Evan talked to you about with AWS cloud services and ground station, it allows you as a user to leverage a global network, take advantage of our infrastructure and security, use the cloud services, and only pay for what you need. So thank you all very much for your time. I appreciate everybody's attention, and look forward to questions after this presentation.
Well, thank you very much, Shane and Evan, for giving me definitely a lesson in deploying solutions at the edge. Now, we will hear about mission value from the source. We have a few innovative startup companies that are redefining learning at the edge. So AWS has brought us an amazing panel that I'm excited for. But I need Wilfred Justin up here to tell us more. Hi, Wilfred. How are you?
Hey, Julie. Pretty good.
Good. Can you introduce yourself to everybody?
Yes, I am Wilfred Justin from Amazon Web Services. I head up a team of artificial intelligence and machine learning experts and help partners and customers to deploy Amazon machine learning stack.
All right. Well, I'm looking forward to this one. I know we have James down there from Parasanti, who's going to be coming up and joining you as well.
Yep.
And JD Stanley just popped in the backstage. All right. Well, I'm going to get out of the way. Enjoy, Wilfred.
Okay. Hey, Jane.
Hey there. Hey there.
Hey, Rajesh.
Hey. Hey, Wilfred.
So this is the real session. Can we get started? Or can you hear me? Or?
Yes, sir.
Okay. So let me share the screen and then we can go from there, right? Okay. Sharing screen. Can you see my screen?
Yes, we can.
Can you see me?
Yes.
Okay. So if we can get started, probably we can start now. So once again, my name is Wilfred Justin. I am from Amazon Web Services. I think today we have James Hancock, founder and CEO of Parasanti. And I think we have Rajesh, CEO and founder of Edge Tensor. And we have JD. The format of this presentation is going to be, I think the whole session is for 60 minutes. And for probably 25 minutes, I'm going to talk about a couple of things, including why people do machine learning at the edge, a couple of use cases that dictates doing inference at the edge. And for those kind of use cases where you need to do inference at the edge, how you can leverage AWS services. And probably we can spend a few minutes on how we can optimize the inference process at the edge. And maybe if time permits, we can talk about a couple of design patterns where absolutely you have to do, based on the data that you collect from the devices and IoT devices, you have to analyze that and probably run some kind of machine learning, but the device is so constrained, you cannot even run inference on those devices. So what we do that, how do we handle those kind of scenarios? We'll spend a couple of minutes, and probably we'll straight away jump into the panel discussion. Does it sound good? So if it sounds good, I'll get started. So you can see my screen. I assume that you can see my screen. To the left, or to the cloud inference is something that we all know about, right? You could collect lots and lots of data from IoT devices, or it could be from anything, right? App servers, web servers, hardware, and a lot of devices. On that cloud inference, and cloud computing platform like AWS is awesome for that, because it provides a lot of big data services using which you can ingest data and process data both in real time as well as in batch mode. So it would let you build some kind of data lake easily, on top of which you can build and train and tune a model, and then the model can start generating predictions. And we all get it, and we all know how to leverage the cloud. But we are going to focus, this presentation is going to focus on the edge inference, where you have to do the same thing, but probably here you're collecting lots and lots of information from the devices, sensor data, but you cannot afford to make an API call to the cloud, and you have to run inference at the edge. So based on that inference, you can take a lot of, how do I put it? Well-informed decisions, which could be for operational efficiency, or it could be for predictive maintenance, and so on and so forth. And we're going to focus our presentation and discussion on the right side, which is edge inference. So to begin with, let's talk about a couple of reasons why customers and partners have to do kind of analysis or machine learning or inference at the edge. It's a no-brainer, you all get it, but I'll quickly go through a couple of use cases, right? One of the reasons could be privacy and compliance. Think about a hospital environment, right? Or a medical equipment, where it could be an ICU where lots and lots of devices are connected, and based on the data, based on the threshold, you have to inform a doctor, or you have to do a couple of things. Mainly here, it could be because of privacy. You have to make those kind of analysis and decision on site, and you cannot send data back to the cloud. But the real reason, most of the time, the real reasons are network latency and bandwidth. And as we all know, there are applications which has to run probably in a zero bandwidth environment, and those applications demand instantaneous inference. And the obvious example that I can give is self-driving cars. You cannot just afford to collect data from all kinds of sensors and make an API call to the cloud to make the decision on how to steer the car. That would be disastrous. So you get it, right? We cannot afford to have round trip time, and those kind of scenarios dictates using inference and machine learning at the edge. Cost could also be a factor for extreme use cases, right? And this one, I got it from Toyota Connected Car, and Toyota Connected Car is one of our customers, and they build on AWS for the backend solutions, as well as for the machine learning. They use lots of services from AWS, including deep lens. So here, as you can see, a connected car has literally hundreds and hundreds of sensors. And for one particular use case where they wanted to use deep lens to provide safe driving application, right? So if the driver is distracted, it should alert and should take some corrective action. So for that, they did a small case study, and as you can see, based on that particular case study, a person was driving the car for 48 minutes. And based on that, they were collecting 7.2 million data points per connected vehicle. How do they do that? Because they had to connect 500 plus unique data points every 200 milliseconds. And if you do the math, it comes around 7.2 million data points per connected device. So extrapolating it, they had a fleet of 7.5 million connected vehicles. So even they did the math and they said even if they're capturing 1 minute of high quality, high definition video per vehicle, the cost of uploading data for analysis, regular analysis or machine learning pattern detection in the cloud, the cost of uploading would be billions of dollars. Of course, the point I'm trying to make is still you can do deep analytics in the cloud, and instead of sending all the data using the network bandwidth, you could use Snowmobile family of products to send it, right? But you get the point. There are a couple of use cases where mainly because of latency and bandwidth, it doesn't make sense to make an API call to the cloud, and you have to do your machine learning inference at the edge. So for those kind of scenarios, I'm going to quickly go through a couple of services, and then we can open it up for the panel discussion. So again, a small disclaimer, I'm not going to talk about different services. I hope the audience who are listening in, we had multiple sessions on machine learning, outposts, local zones, and Snowmobile, a family of products. So I'm just going to focus on architecture patterns and design patterns and a couple of use cases, and talk about how we can leverage the services for implementing machine learning at the edge. So obviously, the first service that comes to my mind is Amazon SageMaker. And Amazon SageMaker is a higher level, fully managed service. And the whole intent of Amazon SageMaker is to help you build, train, tune, and deploy custom machine learning models. It makes the process much easier and simpler. That is Amazon SageMaker. So when you're using Amazon SageMaker for machine learning, it comes with a lot of algorithms. It comes with 17 plus algorithms that is part of SageMaker. But you know what? You can also bring your own algorithm. So you can use Amazon SageMaker to abstract a lot of infrastructure work and expedite the process of building the machine learning model. On the other hand, you may not want to use a high-level service for whatever reason. For in those cases, you can use our Amazon Web Services deep learning armies. And as you know, we are kind of framework agnostic. We want to provide flexibility to our customers and partners, so we support multiple frameworks. So we provide a lot of deep learning armies based on TensorFlow, Keras, Onyx, MXNet, and so on and so forth. So depending on the use case, you can build your machine learning model using that. And of course, you can deploy it using Amazon Cloud Compute, right? EC2 instances. I don't have time to digress on that. We have a lot of instance types, which includes compute optimized, storage optimized. And when it comes to machine learning, you have really powerful instances like P3DNs, which has 100 megabits per second of networking. So that's the point. But so SageMaker, you have to start with SageMaker because you have to build the model. But we are talking about edge computing. We are going to focus on edge. So I'm going to just mention AWS IoT. And probably you would have learned a lot, and you would have gone deeper in a couple of sessions that happened in the last couple of days. So I just want to briefly mention a couple of services. So under AWS IoT umbrella, we have things for analytics. This is where we can talk about site-wise, we can talk about analytics, which means that, think about it, you have billions of devices, and you want to, for industrial application, and you want to quickly collect data from those devices so that you can do some kind of analysis, and you can make well-informed, intelligent decisions based on that. For that, you can use IoT site-wise. How it works, we can digress if time permits. So that is site-wise, analytics, graphs, and so on. On the right-hand side, when it comes to device software, how we are going to provision devices, how we are going to push software into your device and make sure that the devices are updated to the current software and current operating system and so on. And think about it, right? If we have 1,000 devices, that is fine. But if you have a lot of customers that we deal with, literally have hundreds and thousands of devices or millions of devices. So if you're going to do it manually, if you're going to manually push software and take care of the software updates and so on, it's going to be a painful process because of intermittent connections and so on and so forth. So leave that to a service called AWS IoT Greengrass, and Greengrass will take care of pushing the device and pushing the software to the device and so on. I just want you to understand that, because that's what we're going to focus when I talk about inference at the edge. And lastly, let's take IoT Core, and probably during our panel discussion, we can talk about security and compliance. So when you collect data from the devices. Probably devices have to exchange information. How do they talk with each other? How do you take care of data at rest security and data in transit security, right? How do you do encryption? How do you do mutual authentication? Say, for example, you might be using certificates, you might be using encryption, using keys. So those devices have to be provisioned with those certificates and keys, and an AWS IoT Core comes handy for that, right? So those are the couple of services you have to remember. So coming back to our topic, deploying and predicting with AWS Greengrass. So in our case, in both Edge Tensor as well as the Prasanthi solution, we are going to talk about, probably you're using a lot of devices, but how you're going to deploy the machine learning model into that devices. The first step is, as I mentioned, start with Amazon SageMaker, build your model, train your model, tune your model, and then probably you can write an AWS Lambda function for the inference, and then use AWS Greengrass to push the model as well as the Lambda function into the device so that the device can start generating inferences and it can take local actions on the device, right? So that is a simple data flow. And probably depending on if you want to have extracted intelligence in the cloud, you might want to sync back vital pieces of information, including data, back to the cloud once a week or once a month or once a day, depending on the use case and depending on the connectivity, right? So again, how do you do that when you're talking about machine learning at the inference? Train a model in Amazon SageMaker, write an AWS Lambda function for prediction. So add both as resources, Lambda function as well as the trained and tuned model into your AWS Greengrass group, and let AWS Greengrass handle all the deployments and updates. And again, because of the time constraint, I cannot digress to AWS Greengrass, but you can define what are known as groups. A group could be one device, or it could be thousands of devices, or it could be one main device and a group of satellite devices that connects with the main device. So you can configure the group in whatever way it makes sense, and you can use Greengrass to push the software to that based on the groups, resources that is defined in your AWS Greengrass group. So obviously, in order to do this, the requirements are your devices should be powerful enough to run AWS Greengrass, and we can talk about it, right? I think most of the devices like Raspberry Pi, and we'll talk about Deep Lens and a couple of others, they're all AWS Greengrass compatible. So when you're doing the panel discussions, you guys can throw some light on what kind of devices that you use and what are the challenges that we have with that. But requirements perspective, it should have Greengrass, you should have powerful enough to run Greengrass. And obviously, as I mentioned, right, for mutual authentication and encryption, you have to have certificates and keys that should be provisioned by your IoT Core. And probably you can read what is there on the left side, right? It is best when the same programming model is in the cloud and the edge, meaning that you're building the model, you're simulating what is required in the edge in the cloud, and you're just pushing the trained and tuned model to the device. So I'm going to briefly touch on Deep Lens. And why do I do that? Because we have a lot of partners who provide video security solutions like Edge Tensor. And my team is working with at least 2 or 3 partners who are building solutions based on Deep Lens as we speak. So it is custom built for deep learning. It supports many frameworks, including MXNet and TensorFlow. And it is tightly integrated with SageMaker. And it is tightly integrated with SageMaker Neo, which I'm going to talk in a couple of minutes. So that is Deep Lens. For example, I think Toyota connected car built an entire driver safety application based on Deep Lens. So there are a lot of other things that we're doing when it comes to device detection, gun control, and so on and so forth. So again, the concept is not different. In this case, the device is Deep Lens. And if you recall what I mentioned, you're going to use Greengrass and you're going to push the train model. And we talked about the Lambda function for inference into the device. And then the Deep Lens has a camera. As I showed you, it can take the input. And based on the model, it can generate inferences and throw output. A couple of scenarios that we actually use Deep Lens for a lot of sessions, and it detects a lot of people, as you can see, right? But the point here is MXNet, Caffe, and TensorFlow are supported. And it is tightly integrated with Amazon SageMaker and SageMaker Neo. So with that, I hope we can ask questions, but since it is forum, it's a virtual thing, I'm going to proceed. I'm going to give a small pause and then let's proceed. So the next topic is optimizing performance for inference at the edge. I am really interested in this topic, and I'm really keen to know more about how we are dealing with this in our panel discussion. But the point here is the devices, since we are running machine learning at the edge, the devices are not really powerful. They are not like P3DNs or C5s, right? They have a lot of constraints that include computational power, memory power, power consumption, storage, so on and so forth. So if you think about deep learning and machine learning, when you're building a model, and if you want the model to generate predictions with highest accuracy, the models are really large, right? And there are multiple reasons. Once again, we don't have time. The models become really large because the deep learning neural network starts having multiple layers, and it has to do complicated computational tasks. It has to process multiple parameters, and it has to do a lot of complicated arithmetic operations, including 32-bit floating arithmetic, right? So the model becomes really heavy, and when you're trying to deploy that heavy model, large model on a device, which has a lot of constraints, it kind of defeats the purpose, and the performance deteriorates pretty badly, right? And probably you may not be able to use it. So once you have the model, you have to make it smaller and faster for the devices that you're deploying. And there are a number of techniques. This is where I want to really spend a couple of minutes and to start you guys thinking, and we can dive deep into it during our panel discussion, right? So how do we achieve that? People are doing that today as we speak. But again, it is really complicated, right? You have to do code optimization. You have to do you have to reduce the weights, as I told, right? From a larger weights to smaller weights. And there are a lot of techniques like quantization, mixed mode training, and so on. There are other techniques like pruning and compression. The point I'm trying to make is, yes, it can be done, but in order to do that, you have to have not only people who have a lot of expertise and experience in machine learning. Now suddenly you need those developers to have in-depth knowledge on the framework on which they are building. And also they have to know deep knowledge on the devices that they are deploying, because the in-device, the target architecture might be based on Intel, it could be based on ARM processor, it could be based on NVIDIA. So since you have to optimize it for the end architecture, you have to have a lot of expertise in multiple fields, and quickly it becomes really complicated. Say, for example, code optimization. One quick example I want to give. If you're using some kind of device like Deep Lens, and if you're doing some kind of video detection and analysis using Deep Lens, using TensorFlow, you're not going to deploy that TensorFlow framework into Deep Lens, because Deep Lens uses Intel Inference Engine. So you're going to convert that format into an Intel Inference Engine format so that it runs much faster and efficient, right? And there are a lot of open source tools like NNPAC. Similarly, when it comes to a larger model, how do you reduce the size of the model? As I said, in any kind of deep learning neural networks, the weights and activation are 32 bits. And by converting the 32-bit weights into 16 or 8, you could save a lot on both storage, processing power, and even the power consumption, because the 32-bit floating arithmetic are very expensive. Once you convert into 16 or 8, it becomes smaller. The model becomes smaller. It is more efficient, and hence it consumes lesser power, right? So those are the things you could do, and a lot of frameworks do support it. But the next challenge is when you're doing that, right? When you're doing, number one, the first challenge is you have to do a lot of work manually to optimize your model for the architecture. Second, once you're dependent on a framework, the model you have built, tuned and trained and tuned is kind of wedded with the framework, meaning that if you're building a model using TensorFlow, and if you want to deploy the model at the edge device, you need the entire framework on the edge device. The best example I can give is, say, for example, if you're building a C++ application on Visual Studio, or if you're building a Java application on Eclipse, when it's time for running those applications, imagine you have to take the entire Eclipse or Visual Studio into your edge device. that is not practical because the device doesn't have a lot of space, right? So those are the two problems that we have. One is you have to do a lot of optimization. Second, if you're building a model based on the framework, it is kind of wedded to the framework. So that's where you can leverage one of the services from AWS called AWS SageMaker Neo. So Amazon SageMaker Neo is part of Amazon SageMaker, and this exactly addresses the two issues that I mentioned, right? We're not going to spend a lot of time on this, but a lot of time on many things, but I just want to spend a few minutes on this one, right? So the first step, what it does is it takes the machine learning model, which is being built using a framework like TensorFlow or MXNet, and it compiles it into a framework agnostic intermediary format so that you don't need the framework at the edge device. So you have converted into one particular intermediary format, which is agnostic. So all you can do is deploy that. But in order to, since it is done by SageMaker Neo, you don't need the framework, but you need the Neo runtime at the devices. But comparing the framework, if the framework takes gigabytes of space, the Neo runtime that supports most of the devices out there takes only megabytes. So right there, you save 100x on space, right? That is space optimization. That is the first thing that we do. Second, we work really closely with multiple device manufacturers, meaning multiple device manufacturers whose architecture is based on different kinds of processors, like NVIDIA to Intel to ARM and Xilinx. And we keep expanding our relationship with multiple vendors. And the reason is, first, we have solved the issue, right? The wedded model to the framework has been removed, and we are converting the model into a common format. That is number one. Number two, the second problem that I was talking about was optimization. And it's a deep topic, and it needs a lot of expertise. But from a very high level, once we do that common model, common format, we do a lot of things. One, we do compute optimization. This is where we might be doing quantization. We might be doing pruning, right? So we are detecting patterns in the model structure to reduce the execution time, which is the computation time. And also, depending on how the tensors flows between different layers within the convolution in the deep neural network, we detect patterns there in the shape of the input so that we can optimize on memory consumption. So we are doing compute optimization, we are doing memory optimization, and finally, we want to leverage the hardware architecture. So we pass through a low-level compiler as a final stage to generate a machine learning model that would represent the target architecture, and it could be based on Intel, it could be based on ARM, and we try to leverage the hardware vendors' libraries. So if you think about it, probably most of you guys are doing it already. It is a convoluted process, but typically we do a lot of demos and hands-on workshops on this. So when you're doing SageMaker Neo, literally it takes, all you have to do is upload your model, define what framework you have built, and you have to say what is your target architecture, and the magic is done by a SageMaker Neo behind the scenes. So the point is, it drastically reduces your time to market and time to production, and not only that, you gain like 2x better performance on the end devices. So that is SageMaker Neo. And finally, I just want to cover a couple of design patterns before we start the panel discussion. So we talked about a lot of services that you could leverage, but there might be scenarios where local inference is not even possible because the device is so limited in terms of memory and processing power. You cannot even do inference at the device, which means that you cannot push the model, you cannot push the Lambda function. So what happens in those kind of scenarios? There are two things, right? Those kind of devices, most of the devices support HTTPS, or it can support MQTT protocol, right? Let's take device that can support HTTPS. I'm going to go quickly. Yep. So same here, right? You train a model using SageMaker, and as you know, probably most of you have used SageMaker, and deploy it to a prediction endpoint. You can have SageMaker endpoint and you can deploy it. And at that point, it becomes like any other AWS service, right? You have a model, it has an endpoint. You have to make, you can invoke an endpoint using an API. So at that point, what it does is the model is already trained, it is deployed in the cloud, and it has an endpoint. The device, what it does is it collects all the information, because of using IoT and other protocols. It collects information, but when it wants to generate predictions, or when it wants to do some kind of analysis based on the data it has collected, it simply makes the HTTPS post call to the endpoint. It sends the input and it gets the output. So again, I'm going to skip all the details, but you know that, right? Network should be available and devices must support HTTP. The second scenario is devices cannot even support HTTPS. So in that case, invoke a Lambda function, right? Which means that you first write a Lambda function, deploy it through AWS IoT Core. And again, same thing. You train a model in SageMaker, deploy into a production endpoint. So you have a SageMaker trained model, you have an endpoint, and then you have an you have a Lambda function, which is part of the IoT Core. And the devices which cannot communicate using HTTP, they can communicate using MQTT protocol. So they collect the data, they use MQTT as a transport to AWS IoT Core, and IoT Core triggers the Lambda function, which will invoke the inference endpoint and produce the results. So here network is available. So obviously network should be there, but the only difference is in the former, we made a HTTPS call. Here, we are making an MQTT as a protocol. And as you know that it's less demanding, right? And obviously the limitations are, or the requirements are, it has to be provisioned using IoT Core. So again, we can discuss a lot about how we can leverage AWS services for machine learning at the edge. But since we have exactly 30 minutes, I'm going to stop my presentation and we can switch to a panel discussion. So before I do that, let me stop sharing my screen so that I can see you guys. Can you see my screen? Can you still see my screen?
Yeah. No, we can't.
No. We can't. Can you just wait for 1 second? So while I'm doing something, why don't we start with an introduction where you can start with a quick introduction, talk about yourself, your background, your company's vision, and how you're working with Capital Factory. So can we start with JD?
Sure. Is there any slides or not? I just wanted to make sure. If not, just verbal's fine. Okay. So JD Stanley, I was close to 20 years at Cisco. A friend of mine asked me to leave. He was on his 3rd gen product platform. And so we actually are a company that's got a really kind of awesome name. You can see it. It's IoT AI right in the middle of all the hype. We actually grabbed the domain also of IoT.ai, and I have to laugh because I ran lots of different engineering teams, product teams, sales teams, all on this topic for close to 20 years. And so to leave Cisco and get a name and a brand and a domain of that, it's just kind of funny. But at the end of the day, I also have a black box. And so our black box is at the edge. We have been awarded over $5 million in government contracts in the last 16 months. And so we do everything from a communication and sensor environment to distributed analytics. We're also a finalist with AFWERX on JADC2, the MDO type of environment. And so we specialize as sensor experts, communication experts, and the easiest way to describe it is extreme IoT. And so at the end of the day, our company has been about almost 2 years old, not quite, driving the innovations we've had from our past into solutions that actually solve the extreme edge, austere edge, mission side, things around maintenance and training, kind of optimizing those business cases. And then we have sub-components that help in cloud. We actually have some of our components that do run on AWS. We have some components that actually, through a contract with DHA and JHARM, that run on Platform 1 that was talked about earlier today. And then we also have edge components that are really built for really harsh, extreme, really disconnected environments. So it gives you a little bit of background about who we are and what we do.
Thanks, JD. James?
Yeah, how is everybody? So I do want to start out by just saying, thank you to AWS, thank you to Capital Factory. A company like Parasanti, a defense startup, would not have been a thing 10 years ago, right? Without the advent of cloud and without the cheaper compute and without the exposure to, the government functions that Capital Factory provides. But a little bit about Parasanti is we are the blue-collar analytics company. We're geared towards delivering analytics and machine learning to those who've never had it before, right? And really the focus is on IoT, and the focus is on the warfighter, and the focus is on the farmer in the field, right? What we really focus on is the whole data management aspect and how you utilize all of this information at the edge to make tactical decisions in real time to the people who really need it most, whose lives are on the line, right? So my co-founder and myself are former chief architects for the DoD under Hewlett Packard Enterprise. I've got the hairline to prove it for years of architecting DoD systems. But we noticed a real disconnect from the decision making or data sharing that was happening in Stratcom and happening, in the war rooms around the world, and what was actually happening on the battlefield, right? The collecting of all the Internet of Battlefield things, device information from vehicles to wearables to sensors to virtually anything else, and presenting that information or those insights to the people while they are in theater or while they are actually performing a mission. So that's what Parasanti is all about. You see the thing back here, anti-big data, because we do focus on small amounts of data coming from millions of different devices that are interconnected across the enterprise and across the battlefield. So thank you.
Thanks, James. So probably during our course of discussion, we can talk more about it, but I'm super excited that you're helping the command and control to provide operational intelligence in a kind of a zero bandwidth environment, right? But we can discuss more about it the next question.
Definitely.
Rajesh?
Yeah, good afternoon, everyone. So Edge-Tensor, what we focus on is, our mission is to make AI affordable and accessible to the mass market. When I say that, it means that we have developed a very optimized edge AI engine that works on commodity hardware. As I said, we were talking about Raspberry Pi and all of these devices when Wilfred was sharing his slides. So we focus on those kind of devices, and we have built the entire inference engine from scratch in-house, which gives us a lot of leverage. And all the discussions that we had about how to handle the inference, how to handle the data, the memory, the compute, and all of that is basically what we focus on. And then we have built an API that can be deployed on multiple types of architecture, cross platforms, basically, I think the biggest advantage for us is, since we are building it, and we don't have any open source dependencies in our SDK, so that gives us a lot of advantage to deploy it on sub 5 watt devices. And we're also looking into like ultra low power devices, solar powered, and all of that, where quantization, sort of binarization sort of techniques help quite a bit. And from there, of course, we have the entire end-to-end pipeline, the front end, back end, where, because all of the compute that happens on the edge needs to be aggregated on the back end. So we do provide an end-to-end framework where we have video intelligence and analytics, and basically the verticals that we work in is mobility. I think one thing that we touched, Wilfred touched on in the slides, was autonomous vehicles, and we work in that space in mobility for doing distracted driver monitoring, and it's all camera based. So basically, all our applications is driven by real-time camera-based inference. So that's one of the highest sort of consumer of data, bandwidth, and power. So, and then the two other application areas that we're looking into are video security and retail, and then of course there is branches of that like smart health or smart cities and all of that. And we do have NSF ongoing grant with the local university here, where we are developing the next generation driver monitoring capabilities for focused on military vehicles and fighter aircraft and assessment platform and stuff like that.
Very good. Thanks, Rajesh. One thing that was really interesting was your solar powered devices. So maybe we can discuss about it in the next couple of rounds, right? Questions, right? So which means that I'm assuming that you're not only doing software, you're also building hardware, or you might be having some kind of agreement with the hardware provider. We can discuss that later. So JD, coming back, sorry about it. I did some research on James and Rajesh, but I didn't do a lot of research on IoT AI. So I understand, right? But I'm assuming that the use case is going to be predictive maintenance using a rugged device, as well as a couple of other things, right? So can you elaborate on what is a high-level use case, couple of use cases, high-level architecture, how you're using devices, how you're collecting and analyzing data? And I'm not sure whether you're using machine learning, so if you can elaborate on that, that would be fantastic.
Yeah, we have more recent ones, but I'll give you one that describes a lot of what you just mentioned that ties to actually some of our current projects. But a couple of years ago, we actually, about a little over 18 months ago, the Air Force spends about $1.6 billion on hearing loss and health issues related to a lot of noise and those types of things. We've seen lots of issues that the Army itself has faced in that. And so we did a study with Air Force Medical where we basically had a noise sensor that we developed, and it was wearable in the soldier that communicated to our little device that allowed us to have multi-kilometer communications over RF. Inside of both those devices, we had micro kind of machine learning, parsing actual analysis of the noise patterns that were coming. And then we actually tied that back over a cellular network at the time, but we could have done it over a tactical also because we were doing telemedicine. Back to our cloud component, we have an asset that we call collaborate.org. It's a public site out there everybody can look at. It does have an ADS kind of background, AWS type of background, but that's a multimodal, multi-stakeholder, multi-data set, open API, ability to share actually cross sectors. Some of the government and actually private sector are using it for COVID-19 right now. And so what we had in that back end was also some deeper analysis where we did genome analysis of Air Force medical records and identified that there are certain genes that actually give people proclivity to hearing loss. And so we actually took what our learning in the big analytic cloud, transposed that down to those micro machine learning modules, and allowed us then to actually look for giving them a warning light, in essence, of saying, hey, your decimal point based off your profile is getting too high. Here's what you're going to do. And so that gives you an example that we use just some hardware we have developed. That's A2AD, very resistant, mil-spec, but also COTS based. Very lightweight, less than 2 pounds, very low power usage. And then we also tied that to the sensors so we could compute locally in a disconnect. But then we also integrated kind of that edge to cloud to edge loop to ensure that the model locally and in the cloud continue to learn off each other. So that gives you a little bit of background of a use case that kind of relates to a lot of the topic you mentioned.
Awesome, Jerry. That sounds interesting because that clarified one point. You're not only using the devices to collect data to push it back to the cloud where you can do a lot of analysis and predict hearing loss or genome sequencing, but also you're pushing back data to the device, and it also does some kind of machine learning at the edge, at the device itself.
Yeah, no, so a lot of where the market's going and where Amazon, I think, is going, where it's going, and Microsoft, and even Platform One, and what the Capital Factory and also my peers are going, is the nature of the classic client-server model of the cloud works, but when you get to these extreme edges, just like what James was talking about, it's really hard. They don't have power, they don't have connectivity. You are disparate. The mission is actually under constant attack by foreign nations. And it doesn't matter if it's a peer nation or near peer nation, there's constant interference. And so we've actually been optimizing to figure out how to do those things. And that requires the pushing of kind of these micro MLs that are parsed, distributed closer to that edge, but then still have kind of the big brother or the mother back home that says, hey, I've learned something new from the other children.
So that
are you seeing something similar or not? And that's really where the evolution is going, kind of that symbiotic cloud to edge, edge back. But also what's been talked about the last couple of days with the Capital Factory and the Fed Supernova is there is a disconnect moment. And that is a missing gap in the market. And so we, along with my peers, we're all trying to address that as the startups across the military environment.
Very good, JD. Over to James. Can you I understand, right?
Yeah.
It's all about command and control, but how do you handle intermittent connections, how you collect data, and how you handle the challenge of sending the data back upstream when you have limited connectivity? And if you can throw some light on it, that would be
yeah. Well, JD hit the nail on the head, right? You're going to lose connections, and the market we function in, the DoD, is going to lose connections a little more often than everybody else, right? Doing IoT and Industry 4.0 in the middle of Chicago, right, is a lot easier than doing it in the middle of Fallujah, right? So everything about it has to be architected for that environment. So what we do is we have, we talked a little bit about Snowcone earlier. We have our NVIDIA-based GPU devices, right, that can be kind of strung together in a tactical mesh, so we can self-correct our environment in the field, right? So we have a fog network to be operated and to do these machine learning insights and generate solutions to problems with, right? So that functions as one of the problems, right, of us having connectivity to compute. The other major problem is how do we actually use this to operate on the different functions across the C2 environment, right? Yep. So what we do is we actually, and it's kind of similar to what JD's talking about. You kind of have micro machine learning algorithms, right, that perform one single function. But what we do is we have what we call federated machine learning, and it was coined for really keyboards, right, on your cell phone. So you have a local model that's being generated by your typing, and then it sends the insights of that model to the mothership, right, for the aggregate model across the nodes, right? Yeah. So we do that same sort of thing with the in-flight, in-theater analytics or data sources that are being generated, and the added benefit is we can utilize those long-range networks because now all that we're sending across the wire is the insights. We're only sending the standard deviations, outliers, and means across the network, and we can communicate in much wider band communications for in-field analytics and C2 operations, right? So,
great, James. Right, you talked about a lot of technical details, but that is awesome, right? I kind of get it within 5 minutes, but I can do more research on that. Yep. But what is the use case you're trying to solve, right? How you're trying to provide operational intelligence when certain people are deployed in the battlefield?
Yep. So what C2 means to us is, command and control, take all those data sources that are siloed and in different places, deliver it to the end user to actually make actionable decisions, right? So one of the use cases we love to talk about is, taking the wearables off the warfighter, right? There's no shortage of Fitbit type devices. There's no shortage of blood pressure cuffs, even video, right? Taking all of the insights from that, combining that with the diagnostic information that's being put out from the Abrams, right, or being put out from some of the equipment out there. And so a situation we talk about is, hey, this tank driver's blood pressure just has gone through the roof, right? We combine that with the Abrams track vibration going up and the weapons temps going up, and we have the insight of this person's been compromised. This tank's been compromised in some way, shape, or form. Let's send the helo to get them out. Nobody jumps on the comms, right? So that's what we're all about, is saving the warfighter and doing it by connecting all these siloed devices, right?
Very good. Thanks, James. So Rajesh, I think I went through your website. You made it very clear that it's nothing to do with the cloud. You do everything at the edge, and you have proprietary techniques that you have built to optimize and stuff like that. But I think your solution falls under two broad categories, right? One is mobility solutions and video processing and security. A lot of people do that. Are you thinking about using a service like DeepLens, or are you using Raspberry Pi, or just what kind of devices that you're using for your rugged device, and how you're collecting data and how you're analyzing data? And tell me at least one use case.
Yeah, so let me take the mobility use case. What we do for mobility is, as I said, distracted driver monitoring. So we monitor, there's a camera sitting in the vehicle, like you can think about it as a dash cam, and it looks at the driver, alerts him when he's drowsing, distracted, fatigued, playing with his phone or eating, drinking, doing anything that he's not supposed to do other than driving.
Yes.
Here it's again, you get devices that, we get customers are like, okay, 90% of the time it's always like, okay, I have this 4-core device. You know what? I have 3 cores that are already occupied by something else. We have 1 core left. Can you fit your AI SDK on that 1 core? So that's the challenge we get in the real world. So basically, how do you take a machine learning in inference engine or AI in inference engine and fit it into single core operation and still be able to do 15 FPS or or more? So that's the challenge that we have. So, and of course the power is limited, the bandwidth is limited, and all of that. So we typically go for, most of our 90%, I would say, is Raspberry like devices that we focus on. And then just to give you on a 50,000 feet level idea about how things work. It's mainly the power is drawn. If you look at any ML architecture, it's all about bringing data from DDR to the cache. So if you are able to optimize your models and also prune your inference engine well, and again, the thing is, like, if you are in a application where I want to have 10,000 object detection or classification, that's like there's always a model bias there, and you have inequality in the amount of data that you get per class, all of this. So in our case, we have made that kind of we know exactly what we're looking for as an end product, so we can now tune the data according to what we're looking for, especially. So that gives us a significant amount of benefits to quantize the models and to optimize the model and fit it into like a sort of a cache-friendly architecture, if you may say, where we make a very 10% round trips to the DDR, and then we can fit everything in just real time, single core, and all of that.
Thanks. I really wish we had another 45 minutes, but we have only 10 minutes. People are pinging me, but still I want to cover a couple of important points, right? So Rajesh, say, for example, I know since you're doing a lot of video processing, I'm thinking that you might be doing a lot of pre-processing of the image because the device that you're using might capture the whole frame, but you might need only a portion of the image to do your machine learning and so on and so forth. But since I really want to dive deep on multiple things, but we don't have time, but I want to cover at least 2 more things, right? One is security at the edge, right? That is the key thing. We all get it, right? We understand the device constraints, computational constraints, memory constraints, and so on. That's the reason you're doing it. But whatever solution that JD and James and everybody explained, the devices have to connect and exchange information. And in that case, they have to do, especially when you're doing it for a DoD mission, security comes first, right? So I'm just curious how you're handling mutual authentication between devices. Is it based on certificates? How you're doing encryption of the communication and so on and so forth. So if everybody can spend a couple of minutes on that, I still have one more question that I want to get to. So JD, can you, you're on mute.
Yeah, so we actually handle it in multiple different ways. And so our devices are extremely sophisticated to where parts of the defense have actually verified that it's everything from physical to motherboard to kernel to chip to software to actually dual wrapped encryption network.
Yep.
So that entire stack is very resistant.
You're talking about FIPS here.
Yeah, so there's a whole bunch of different techniques, but the stack is there. We support over 4,000 different types of sensors natively today. But there are actual different types of sensors, biochem through to IoT vibration. We have some industrial customers, industrial control systems. And so because we support those type of native analog and also digital signals, we actually have multiple levels of attributes that are also keyed. When I was at Cisco, I actually worked on how to drift AI systems. Some of my teams were doing that. And so that was my final couple of years there. And so we know a lot about the risk of drifting AI, the risk of human assumptions in AI. And so we've actually countered some of that in our system. But in general, we also are very open to the actual RF networks, the encryption models. And so we have trusted forms that allows us to communicate up through other tactical environments or satellites, commercial satellites, 5G, 4G. But we also have zero trust models that also allow us to do that. And so the level of sophistication isn't just a software level. It actually is from the physical up through to the network, and then the data, and even some of the ML. We have signature analysis of ML to ensure drift analysis, to make sure some of that stuff isn't occurring that can occur through malicious techniques. And so there's a lot of details to that, but it gives you a sense of how we've tried to address the edge, which is very unsecure in a lot of cases, and very multi-party based, to where we support third-party AI, like, for example, our Justice stuff would probably work on our types of devices. And we also support third-party sensors. And then we also support third-party data exchanges, because everything has to be heterogeneous. There is no forklift upgrades in this environment. And so you have to be able to interoperate. And so we do support all the security protocols, but we've added in some of our secret sauce to kind of help ensure security at those kind of extreme environments that you don't have complete control of. There's a lot of uncontrollable brinkmanship that occurs at the edge.
Yep. Awesome. Thanks, JD. James?
Yeah, so we could probably have a whole nother hour conversation on security at the edge, right? So, you know, how we handle it is everything we have is fully encrypted at rest and in flight, right? We have containerized platforms or everything's containerized, so everything is segregated, right, from the other users on the platform. We also enable a lot of Devsecops processes, right, to where everything is tested before it's built and before it's actually pushed to the hardware devices itself. And then kind of, you know, going back to our federated model, right, we do have, it makes it so we're distributing the insights across the network. So no one node actually has all of the raw data, and no one node has all of the insights, right? So everything is kind of separated in that way, and that if you do compromise a node and you do somehow get through multiple levels of encryption, you're not really getting the entire picture of what's going on, right? So,
thank you, James. Rajesh?
Yeah, so we use a combination of keys and encryption, and then of course there's a two-level authentication that happens on the device. And with respect to software, there is license encryption and you know, keys that we use to you know, handle all of these at the edge. So you know, and since we are not in military, I think there are some you know, some things that we need to, you know, consider as well. And I think what you guys presented looks very interesting to me. I just wanted to mention also about your cross-platform deployment, which is always a concern for us, because there is no manpower. You can do that in a finite time. It takes a lot of bandwidth from a startup. So I think SageMaker Neo kind of application is quite relevant for startup like us.
Thanks, Rajesh. So we have exactly 3 minutes, so I'm just going to give you 1 minute each. So this is where I'm strong. Definitely, I'm going to connect with each one of you individually, because I strongly believe, based on the use cases that you presented, there is a scope for, in a selfish way, we can think about SageMaker Neo for one, an IoT core for encryption and security, right? But having said that, any last thoughts around best practices, lessons learned, and probably each one of you can take a minute, and we can close the session with that. Over to JD. You're on mute.
Yeah, the market's full of hype. We all use the same language, which is hard, right? And so ultimately, what's good is that what Capital Factory's done to put this together and to see what AWS is doing. And so a lot of this is interoperability. And so you will always have a bigger back-end connection for startups and a global scale. And that's something we have leveraged. And so my word of advice to any startup is to consider how you can leverage this in your early days of a startup, because it does help you scale. And then also for the mission side is that we all have a passion for it. It's a big problem, and it will only happen through collaboration across the sectors and across the startups to really kind of help drive that. And so I just thank you for being part of this, and thank you for the work and the sponsorship that Deloitte and you and Capital Factory have done today.
Thanks, JD. James?
Yeah, just echoing that same sentiment. You know, we wouldn't be here without AWS. A lot of the testing and building and every part of our solution is based around what AWS has been able to give to us. And, you know, we appreciate the platform and the opportunity to speak today. So thank you.
Thanks, James. Rajesh?
Yeah, I think I second JD as well, and thanks Wilfred, and thanks AWS and Capital Factory for putting this together and giving us an opportunity here. And I think more and more scalability is a big issue for us, for any startup, I think, in early stages. So you can do number of POCs, and beyond that, when you get to like 1 million devices, how do you handle that? How do you do over there updates and things like that? I think if these things we can handle it at an early stage, as JD mentioned, I think that will be a really game changer for startups. And then I hope we can get some help on those lines.
Sure. Thanks again for your thoughts and best practices and lessons learned. And definitely from my perspective, I think we have to dive deeper. I'll connect with each one of you individually and try to find out how we can help you better. Once again, thanks for your time and thanks for using AWS.
Thank you, everyone.
Thank you.
Stay safe and healthy.
Yeah, bye-bye. Thanks.
All right. Well, I'm going to keep the thanks going. Rajesh, JD, and James, thank you. And a big thank you to Wilfred for bringing everyone together to talk about the Battlefield Edge. It's award ceremony time. Jump on over to the AFC Innovation Combine track or open up to the startup call. Both are about to open. We've got about 30 seconds, so hop on over. Tomorrow morning start time, 10 a.m. We have the Human Performance 100K Award Challenge, so see you then.
I wanna know, wanna see it. Can I feel your grip tonight? Can't get this off my mind. Does it only control you? Let me in, I'll help you out. I won't lose you this time. Can I feel your grip tonight? Can I feel your grip tonight? I wanna know what to say. Can I feel your grip tonight? I'm here to hear you say you're fine. I wanna know, wanna see it. Can I feel your grip tonight? Can't get this off my mind. Does it own you, control you? Let me in, I'll help you out. I won't lose you this time. Your finger dizzy from being spun, hung on every word, yeah, every single one. So this is not for na-na, unless I say oh na-na-na. Have all that days oh na-na-na. I'm hard to love oh na-na-na. God knows I need you oh na-na-na. And when push comes to shove, forever is never enough. When I'm with you and don't fall apart, you make me feel like I have all your beauty is my kryptonite. I don't wanna go another night. And when push comes to shove, forever is never enough. So this is my phone, na 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 phone, na 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 na. Slow, automatic, from a movie, cinematic. Your beauty is my kryptonite, and I don't want to go. So this is na-na-na. Promise to say you na-na-na. We have a madness on na-na-na. I'm hard to love oh na-na-na. I never thought I'd find someone. God knows I need you na-na-na. And when push comes to shove, forever is never enough. When I'm with you, I don't fall apart. You make me feel like I have a heart. Your beauty is my kryptonite. I don't wanna go another night. When push comes to shove, forever is never enough. They put us together, don't let them tear us apart. We've come through life, got it hard, and we just need one restart. Just tell me you love me, forever is never enough. Just tell me you love me, tell you love me, forever never enough. Oh, no, 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 oh, here for you, babe. I've loved you the same this whole time. So tell me, what's on your mind? And I'm not here to hear you say you're fine. I can take the pain you hold inside. I wanna know, wanna see it. Can I feel your kryptonite? Can't get this off my mind. Does it only control you? Let me in, I'll help you out. I won't lose you this time. Can I feel your kryptonite? Can I feel your kryptonite? You think you're too far, but I'm where you are, you know. I said I won't leave your side. They left you bare, but I'm begging you, stare in my eyes for you. Yeah, I give my life. Yeah, I'm not here to hear you say you're fine. I can take the pain you hold inside. I wanna know, wanna see it. Can I feel your kryptonite? Can't get this off my mind. Does it only control you? Let me in, I'll help you out. I won't lose you this time. Can I feel your kryptonite? Can I feel your kryptonite? I wanna know what to say. Can I feel your kryptonite? I'm here to hear you say you're fine. I wanna know, wanna see it. Can I feel your kryptonite? Can't get this off my mind. Does it only control you? Let me in, I'll help you out. I won't lose you this time.